If you want to crack Databricks and PySpark interviews in 2026, you need to change your strategy. Because instead of asking those surface level basic questions, interviewers are asking real time scenario based deep dive questions. And not just this, interviewers have started prioritizing these three areas: coding, but with concepts, architecture and design, and third, optimization. So after talking to so many people, I have created this complete Databricks and PySpark interview guide, which will cover system design questions, architecture level questions, PySpark coding questions, conceptual questions, optimization techniques, and much more. So by the end of this video, you will be able to tackle any question related to Databricks and PySpark with respect to the modern questions. And the best part, each area is covered with full of cool live demonstrations plus labs so that you can remember and understand the concepts better. And all the notes are provided with this video so that you can just refer those things in your revision session. So if you are dedicated enough to crack your dream role this year only, then you should watch this video. And if your answer is yes, let's get started with this amazing Databricks PySpark interview guide, and just hit the subscribe button right now if you want to support my work. And now let's get started.
So what's up my fam? Happy Sunday. Excited for 2026? If not, now you'll be excited. Why? So now I know that you are trying so hard to get your dream job, to get your dream role, dream company. I know that. And I know that you also know that Databricks and PySpark, this combination is growing very rapidly. Every job description is talking about PySpark Databricks, Databricks PySpark, PySpark Databricks, and so on. Other skills and technologies are there, but Databricks and PySpark is there. And you know what? I was just talking to so many people and I have analyzed one thing. People have the skills, people have the knowledge, people have some projects as well, but still the pain point is something else. What? First of all, questions are updated. Okay. Because there are so many upgrades in PySpark. Yes, because we are living in Spark 4.1 era. In Databricks, because there are so many upgrades, like aggressive upgrades in Databricks. So that is why the dynamics of the interviews are totally changed. This is one pain point. Second pain point is when interviewer asks you a question, interviewer will start from a scratch, the surface level. That is fine. But when the interviewer asks you follow-up questions, when the interviewer goes deeper and deeper within that topic, that's where people stuck. That's where people are stuck. Why? Because they have surface level understanding. They have encountered or they have already solved those surface level questions, but they didn't go much deeper. So I was like, Ansh, we need to solve this problem and we need to make this solution available to every single data family member. Yes. So if you are my data family member, very good. If you are not, just hit that subscribe button right now, because I'm literally putting my heart into this channel so that you can grow, you can crack your dream roles. And if you just want to support me, support my hard work, just for my motivation, just hit that subscribe button, please, please, please. So jokes apart, because I know my data fam is so loyal, they will just hit the subscribe button right away. And obviously the new ones as well. Welcome to the family if you have hit the subscribe button. So now in this particular video, what we are going to do, we are going to do something which is a kind of distinguisher for this video, and you can also say it is a kind of X factor for this video. We're gonna pick real-time scenario-based question, because it is very easy to answer the questions like, hey, what is Apache Spark? Hey, what is PySpark? Hey, how PySpark is more useful, how it is optimized. It is very easy to answer these questions. But when interviewer gives you the scenario and say, solve this, write the code for this, you are working as a data engineer in the XYZ company and your manager asks you to do this. This is the scenario. When you get these questions, you need more practice, extra efforts to crack this, because you are already in the panic situation while sitting in the interviews. So you are not very well versed with these kinds of questions. So that is why we'll be covering real-time scenario-based questions. One thing. Second thing is I will be discussing and clearing the conceptual part of the question as well. So let's say we are discussing a question about Spark streaming. I will cover the concept as well. Why? Because I know that you have surface level concept ready in your mind, but you need to understand the entire concept, because the follow-up questions will be based on that concept. So as I said, the third thing will be, we will be covering all the follow-up questions as well, all those mini questions, all those small challenges that can hook you, okay, in the interviews, but you will be prepared in this particular video. Make sense? Make sense? Make sense? So this is a kind of solution to the problem that currently industry is facing. All the candidates, all the applicants. Make sense? The issue is not that you do not have the skills. Issue is not that you do not have the knowledge. Issue is interview questions are evolved as well. You need to change your strategy. Make sense? So now let's quickly discuss the agenda. Okay. And let's quickly discuss the prerequisite as well. You are sitting in the Databricks and PySpark interview. So obviously I will say you need to master Databricks and PySpark. Okay. No non-negotiation in that. Okay. So now let's quickly discuss the agenda. If I look at the agenda is very much detailed. We're going to cover PySpark coding questions, and let me tell you, this PySpark coding question will be intermediate and advanced level. We are not covering those basic, those childish questions, okay? We are not covering that. We are covering advanced ones that are coming in the interviews more recently. Databricks architecture questions, because Databricks has changed so much, so you need to update your knowledge in terms of architecture as well. And if you are smart enough, you should know that in the data engineering interviews, you will be asked architecture level questions as well. Databricks coding questions for sure. Delta Lake optimization questions, yes. Spark streaming questions, yes. Apache Spark system design questions, because this is also there in the recent interviews. Databricks SQL warehouse, yes, because being a data engineer, warehousing skills is also there. Databricks optimization questions. Optimization is everything, so we will be covering optimization questions as well. And then obviously some AI related questions with respect to Databricks. Okay, not like generic AI questions, but yeah, with respect to Databricks and PySpark, that's it. So this is the agenda, and let me just tell you, again I'm mentioning this. This is a kind of category of the questions that we're trying to discuss. Do you know what? We will be covering everything in detail, plus with live demonstration, with cool graphics. Let me just show you, because all the notes, all the code examples, all the live demonstration will be provided to you in my GitHub repo. I can just show you right now. So this is the GitHub repo for this particular video, and this is the kind of, you can say, guide or live demonstration that we'll be just discussing throughout the video. And now you can also download it just to have a quick revision just before sitting in the interviews. You can actually download it, or you can just see it in this repo. It's your choice. If you are downloading it on your machine, this is a .svg file. So I will ask you or recommend you to open this in a browser. So instead of opening it in a, you can say, in your system, in your local gallery, no, this is an SVG file. So you need to open it in browser. So it will look like this, for better visibility, for better structure. So we're gonna cover everything with cool graphics, with cool demonstration, so that you can just remember these things, because you need to understand the things. So this is just a snippet, quick snippet for everything that we are discussing, and all these notes will be provided to you so that you can just enjoy while learning. Make sense? So this is, in short, a complete package for you for your interviews. Okay. And what will be the outcome of this video? Number one, you will be well versed with all the questions, plus the concept within the questions, plus the follow-up questions for that question. 3 things are done. Second thing, you will have this quick interview guide that you can refer before sitting in the interviews. And third thing, you will have the right approach to solve the question. Because obviously, questions will be different in different interviews. Once you understand the approach, like how to start answering a question, how to approach a question, that is the game-changing thing. You will learn that as well. Sorted. That is the agenda of this video, and here comes my favorite part of the video, because I feel so happy. It brings a big smile on my face when I share this news, because this is so special. See, congratulations to all of you. So these are the people who have recently cracked their dream offers, and they are so happy. They are happy. So I am happy. And now you'll be like, what did they do? Bro, they just follow the content of this YouTube channel, and that's it. And they followed the guidelines. They followed the instructions, basically suggestions, recommendations, whatever I just give them throughout the video. So yeah. Okay, by the way, we have so many other people as well. So congratulations to all of you. 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 I'm so happy. and I always feel so happy by just looking at these comments. And I'm like, trust me, I'm so happy for you, and you should also be happy for them. And yes, I will also be happy for you. And I know, I'm so sure that this year you will also crack your dream offer, and you will also crack your dream role, and you will also comment on the videos on this channel. Make sense? So yes, just follow me on these handles if you want to, if you just like my work, if you just want to show some appreciation. So you can just follow me here. And now let's get started with this amazing Databricks and PySpark interview guide. Let's do it. So now let's try to discuss this first question, and I want to start my video with this first question because this is one of that old school type question, and this is still relevant. And this is that type of question which is very simple to answer if the interviewer is not smart. If the interviewer is smart, you can be tricked into this question. And to my knowledge, I would say in 90% of the cases, this will be your first or second question. So this will actually set your first impression on your interviewer. So you need to answer this question very carefully. And let me just tell you what is this question. So question is very simple. You have a Spark job that needs to process 10 gigs of data every time. Okay, makes sense. So let's say you are having some sources, right? And you want to process that data, and the size of the data is 10 gigs in every run. Okay. Now, how would you decide the number of cores and memory per executor for this job? Explain your reasoning. Now I know there are so many formulas to just quickly answer this question, but this question is not just about memorizing the formula. This question is more about understanding the concept, because interviewer can hook you in this particular round. And I have seen so many students or basically so many applicants getting hooked in this question, because this question can really cook you hard. Okay, but not anymore. I am here to tell you everything from scratch. So first of all, in order to answer this question, and don't worry, I will just provide this notes and every explanation in my GitHub repo. You can save it for your interviews. Just give it a shot before your interviews, and then I will be just waiting for your good news in my comment section to just read your comment. Hey, we got placed in this company. Thank you so much. So yeah, I am really excited for that. So that's why I'm creating this video. Okay, so now let's do one thing. Let's try to answer this. Okay, let's try to answer this. So in this question, first you need to understand what our executor, how our executor looks like. What do we have in our executor? So in our executor, let me just say solution. Okay, so perfect. So now in our executor, so let's say this is our executor. Make sense? This is our executor container basically, or you can say executor. Okay, perfect. So now in this executor container, we have three major things. The first thing is we have reserved memory, which is 300 MB. Make sense? Then we have something called as user memory. User memory is 40% of rest of the memory. Okay, 40%. And then this is called executor memory. Okay, this is 60%. Make sense? So this is 300 MB fixed. Okay, makes sense. This is 300 MB fixed. This is 300 MB fixed. Okay, now this is 40%. That means rest of the 40%. So let's say this executor size is, let's say just for an example, let's say this executor size is let's say 10 gigs. Okay, this executor has 10 GB of memory. Make sense? So this will be like 300 MB. This will be 40% of 10 GB. How much is it? It will be 4 GB but minus 300 MB. So this will become 4 GB minus 300 MB. Make sense? Simple, nothing fancy. Okay, and this will become 6 GB minus 300, because 300 MB is fixed MB, like fixed, you can say memory. Make sense? Okay, makes sense. So now you will say, Ansh, Lamba, why do we need this information? Because it will help you to answer this question. Otherwise, you cannot answer this question. And if you understand the structure, then let's say interviewer can ask you anything around this question and you will be able to answer it very easily. Make sense? So this thing is clear. Now we know one thing, that this is the memory that we are concerned about. Make sense? This is the memory that we are concerned about. And just to tell you, if you are confused about the naming convention, this executor memory is also called as Spark pool memory. This is also called as unified memory. This is also called as Spark memory. So do not get confused. Let me just write all of the names, because this particular memory has so many names. Spark pool memory, or you can say unified memory. Okay, these are some more popular names, so do not get confused. The meaning is same. Okay, I also call it as executor memory. It's fine. So now one thing is clear. We do not worry about this user memory. We are not worrying about this reserved memory. We just need to take care of this particular memory, right? So what will happen? This memory, only this memory will be bifurcated. Oh, okay. This memory will be bifurcated into two major parts. What are those two parts? So those two parts are, first is reserved memory, or basically you can say storage memory. A lot of people say it as well. So storage memory. Now what is the storage memory? Storage memory is the memory where you cache your data. Cache. It is storage for it is used for caching. Okay, that is fine. Now this is the memory which is called execution memory. Make sense? Execution memory. Okay. Now this is the memory that you are concerned about. Yes. See how we are just breaking down the memory. So now you will say, Ansh, Lamba, one basic question. What is the partition size of this thing? Like how we can just divide this? This is not a hard or basically hard separation. This is a like kind of soft separation. You can just change this value, but by default this is 50%. So this will be 50%. This will also be 50%. You can change it. It's not like that, and it is dynamic, but let's say this is 50% hard separated as well. Not a big deal. Okay. So this is the, you can say, breakdown of your executor container. Make sense? Now you are concerned about this memory, this one. Make sense? You are concerned about this memory, execution memory. This is the memory that you need to decide how much do you need, because rest of the stuff are what? Rest of the stuff are just like, you can say, your other things that you need to just process the data, like storage, user memory. Those are good to just, you can say, make some things available for your execution, but not for actually the execution memory. Make sense? Make sense? Make sense? So what you can do, you now need to find out how much execution memory do you need. Make sense? Okay. So now let's try to do that. It's very simple. And let me just tell you what will be the answer for this. So now you have the data to process 10 gigs of data, right? 10 gigs of data. 10 gigs of data. Perfect. And we need to find how many executors we will need and how many cores within that executor and how much memory do we need. Simple. Okay. So now let's jump on to the final thing, because now you have understood this. See, this is the base of everything. This is the base of the answer. Sorted. So now what I will do, I will simply tell you that each partition. So if I have, let's say, 10 gigs of data. Okay. I have 10 gigs of data. Now this data is equivalent to how many partitions? It is equivalent to 80 partitions. Okay. Ansh, Lamba, stop. How did you find that? So each partition is of 128 MB. 128 MB equals one partition. This is the partition that we get on the block level. This is how the data is stored in the data lake. Okay. 128 MB equals to one partition. 10 gigs of data means 80 partitions. Like I am a mathematics student, so I know how to calculate it. Just kidding. Because I have solved so many questions like this. So I know like 1 gig of data gives you 8 partitions. So I just multiplied it by 10. So yeah, 10 gigs of data equals to 80 partitions. Okay. So now this is fine that we have 10 gigs of data. That means we have 80 partitions. Wow. This is amazing. This is a like very useful information. That means we need at least 80 cores. How many cores? 80 cores. Perfect. One part of the question is solved. Right? One part of the question is solved. Now you will say, Ansh Lamba, how did you figure it out? How? Like we have like 80 cores. So this is again the fundamental of PySpark, that whenever you need to, let's say, perform any kind of parallelism, each partition means each task, and each task means each core. Again, one partition means one task, and one task means one core. Make sense? So that means we would need 80 cores. Okay, make sense? So one part is done. 80 cores. Make sense? Now, Ansh Lamba, the other part of the question says how much of memory you need per executor. Okay. In order to answer this, you first need to decide how many cores you need to put in your executor. Okay. You can assume this as 4. You can assume this as 8. Usually in the real world, we keep 8 cores per executor. If you will use any kind of modern platform like Synapse, Databricks, you will see the virtual machines with 8 cores installed in that, right? So let's say we have 8 cores per executor. Make sense? So this 80 cores means 10 machines. Make sense? Common mathematics, right? Basic mathematics. So this 80 cores means we have 10 cores. Oh, sorry, 80 cores means we have 10 executors, right? 10 executors. Make sense? Make sense? 10 executors, right? So now this 10 executors means that we have 10 machines basically, because in the modern world, we do not host multiple executors per node. We just host one executor per node. That means we have 10 executors means 10 machines. Simple. That is fine. That is fine. 10 executors. Okay. So we have 80 cores, we have 10 executor, and you know the reason. Let me just write the reason for you. Otherwise you will say, Ansh Lamba, why? Because one executor has 10 cores. Oh, sorry, 8 cores. And this is assumption. You can assume anything. You can assume 4 and then you can just find the calculation. You can assume 8, 12, 16. And whenever you will be answering this question, you need to tell this to an interviewer. I am assuming that I have 8 cores. If you have a special request, do let me know. I can recalculate it. Simple. So you can talk to the executor like this. And yes, you can. Do not feel afraid, because he or she is looking for you. I know like you are also looking for the job, but that is also like a person who is desperate enough to hire you. So chill. So one executor has 8 cores, assumption. So now how much memory do we need? This is the most trickiest part. How much memory? Our number of cores are done. Number of executors done. Now memory. Memory. Okay. In order to answer this, you need to revise this concept. So whenever we talk about executor, how much memory we do actually get for the execution process? How much? Okay. So we get 60% here. Okay. Obviously 60% minus 300 MB, but just for the simplicity, let's say 60%. Make sense? 60%. Because obviously 6 GB minus 300 MB, it's like 5.7 GB. So near to 6 GB. Okay. So let's say 60%. Okay. And after this 60%, we only get 50% of 60%. That means 30% of the total execution memory. Make sense? Bro, simple mathematics. 60% is for executor memory. Perfect. And then this 60% will also get bifurcated into two things: storage memory and execution memory. Execution memory is 50%. That means only 30% of the total memory. See, 50% of 60%, that means 30%. Simple. So that means my executor has 8 cores. Okay. That means it will be processing data equals to 8 cores means 8 partitions, right? 8 partitions, 128 MB each. Make sense? 8 cores equals to 8 partitions, 128 MB each. Make sense? That means equivalent to 1 GB. Wow. 1 GB of data. Make sense? Simple. Bro, this is very simple, okay? 8 cores equals to 8 partitions, 128 MB each. That means 1 GB. That means my each executor will be processing 1 GB of data. Wow. That means my executor will be processing 1 GB of data. Yes. Yes. And we just have like examined our execution memory. That means we only get 30%. We only get 30% of the memory to actually execute the data. So in order to execute 1 GB of data, I would need at least 3 times of the data. At least 3 GB of, you can say, memory. See, because I know if I will assign, let's say 1 GB of data, or let's say if I assign, let's say 1 GB of memory to my executor, what will happen? It will only get 300 MB out of it because of this calculation. So if I want to process 1 GB of data, I need to pass here 3 GB of memory, so that let's say 60% of 3 GB means 1.8 GB, and 1.8 GB divided by 2, that means 900 MB. 900 MB. Make sense? Closer to 1 GB. Closer to 1 GB. Make sense? So I need at least more than 3 GB to process this data. Here is the answer. So we need what? We need at least more than 3 GB of memory per executor. Now here's the thing. We can also say we need 3.5 times, or we can also say almost 4 times. 4 times is a like safer bucket. I personally like keeping it as 3.5 times because I know it will work. Plus this 50% of the memory is also like soft, deallocated. Okay, so you can also use it. So my answer will be like, I would define 3.5 times, basically 3.5 GB per executor. Okay, and the reason is based on the memory allocation, or basically you can say Spark pool memory allocation. Make sense? I hope it makes sense. It was like very simple. 3.5 times, and you know why I have put here 3.5. This is the most important thing. Why I have put 3.5 times? Reason is memory allocation. Make sense? Perfect. Memory allocation. Okay, memory allocation 3.5 times, basically 3.5 GB per executor, because we need 3.5 times. Simple. Okay, makes sense. I hope like it was very simple. Like it is not complicated, but yes, if you now know end to end, like this thing, everything, then it is very simple. Otherwise, interviewer can trick you. Interviewer can just cook you very hard. Let me be very honest, but now you know everything. Now just say, bro, just ask the question. Now we know everything. Just ask follow-up question and we will be able to tell you everything. Okay. And every solution like this is already in the notes. I'm again repeating, so you do not need to worry about taking notes, taking everything. This guy is here to help you out. Do not need to worry. Just trust this guy and just show your love in the comment section. Why are you not showing your love in the comment section? Why? You do not need to feel shy if you are on this channel. Okay, just help the other members as well, because when you will be commenting, other people who are new to this channel will have some assurity. Okay, we can trust this guy, and you need to make sure that. Make sense? Okay, now let's jump on our next question, which is very interesting. So let's talk about this question. This is more of a modern type question where you will see like questions like this very often if you are sitting in the interviews more recently, because this is the combination of Delta Lake plus Databricks plus PySpark plus optimization. So it will test you in so many areas. Okay, so let me just read out the question. You are working as a data engineer in a company where daily ingestion jobs write data into a data lake. Okay, delta slash parquet. Okay, over time storage is filled with thousands of small files, causing slow query performance and high job runtimes. If you have worked with PySpark, okay, and if you have worked with PySpark more recently, you would know about this problem called slow query, or basically not slow query, basically small file problem. This is a very common problem nowadays. Small file. This is a very common problem. Okay, if you have worked with PySpark, if not, no worries, I will just explain you the problem. So how would you tackle the small file problem? Now there are two paths again. While writing the data into the data lake, after the data is already written. After the data is already written. Very good. Now in order to answer this question, and if you want to understand this, I will first answer the second part. Okay, makes sense? Then we will just go to the first part. Only then you can understand it. Otherwise you will be confused. Okay, makes sense. So now the situation is very simple. Let's say you are a data engineer and you have some data. You are a, let's say, data engineer. Let's say this is you. Okay, so let's say you are a data engineer and you are obviously doing some PySpark work, some data engineering work, right? And you are writing this data into this data lake. This is your data lake. Okay, this can be like anything. Okay, this can be anything. This can be, let's say, your Azure data lake, your OneLake, your AWS data lake, anything. Make sense? Okay, so for now let's consider as do we have data lake, ADLS? Do we have? Let's keep this one. I like this logo. Okay, perfect. Let's say you are using this OneLake or any kind of data lake. Okay, makes sense. Now what will happen? You are running your jobs on a daily basis, maybe on hourly basis, maybe on, let's say, multiple times in a day, whatever. Now you have so many files. You have files like this. Let's say one file. Okay, let's color it as green. Okay, so now you have 1, 2, 3, 4, 5, 6, so many files. Okay, so many files in short. Now the thing is, bro, this is not optimal because when we have so many files in the data lake and when we are just trying to query this data, this will not be very performant. So let's say there's a data analytics team here who is running some kind of analysis. Do we have report? Let's say we have reporting team here. Okay, now this reporting team is complaining a lot and they are saying, bro, this is not very much performant and we have to just run or basically wait for so long just to run some simple jobs and we cannot do that. This is not optimal. So in those scenarios, you cannot rely on this one. This will not gonna work. Now this is the exact question. Now how you can just tackle this problem. So second part, after the data is already written. Now let's say this is your data lake. Make sense? Now this data is already written in the data lake. Now you want to optimize it so that reporting team will be happy. Not just reporting team, analytics team, reporting team, business managers, anyone who is just using this data. Now what you will do, you will use something called as optimize command. Okay, optimize command in the delta lake. Optimize command in the delta lake. I can also share the code. It will look like this in the SQL. So it will be looking like this. Optimize. Okay, table name. And that's it. This is a command that we use nowadays in order to tackle this problem. Now the fun part is, interviewer can ask you what is the magic behind it and how it works, because a lot of people can memorize so many stuff obviously, but nowadays that is why competition is so high, and that is why interview is so difficult, because they are asking you why part as well and how part as well. So when you write optimize command and you run this command against this particular data lake, what will happen? All these files, let me just tell you what will happen. All these files will be coalesced. Will be what? Will be coalesced. Let's say we have 6 files and these 6 files will be coalesced into these two big files. Wow. Yes, this is the magic of optimize command. This will be converted into these two files. So here are the small files and here are these two big files. This is the magic of this optimize table command. This is the magic. And then again, this 6 files are transformed, and now reporting team is happy because now reporting team can do its work using that particular data instead of this one. So now your reporting team is actually using this data. Which data? This data. Perfect. Now you do not need to use this one. This is converted into this. Let me just write coalesced. Okay. Coalesced. Okay. Makes sense. This is coalesced. Simple. This is the power of optimize command that we have in the Delta Lake. And now you know the reason as well, what happens behind the command. It's not just like you're memorizing the command. Just imagine you are sitting in the interview. You know the answer. You will say, yeah. Optimize command will do the work. And then person will just say, how? And now it'll be like, that I don't know, but now you know, right? Now you know. Okay, perfect. Now let's try to answer the first part as well. This is fine when we have the data in the data lake. Now let's try to understand what will happen when we want to tackle this problem while writing the data. This is more recent version of this optimize command, and that is why you also need to know. So the thing is, let's say you are using any executor, makes sense? And you have so many cores in that executor. Obviously, each core will output some data and it will generate some file. And now we know that the size of file is not very, very big. So what will happen? What will happen if we want to coalesce or basically optimize our data while writing? Okay, while writing, not after writing, while writing, we can use one command called optimize write. Optimize write. This is the command that we can use. Okay, what's so magical in this command and how it will just solve the problem? So optimize write command, what it will do, it will coalesce the partitions while writing. While writing, before writing the data in the data lake. Before writing. Okay. So let me share the code with you. So what you will do, you will simply write df dot write dot format. Let's say delta. Then you will say dot option. And here you can simply say optimize write equals true. Simple. This is your command. And then obviously you can just mention mode, whatever mode you want, let's say append. Okay. And then obviously dot blah, blah, blah. Okay. So this is your code. So when you do this, then your data will already be optimized and you do not need to worry about coalescing and all the things that we are doing after the data lake. Now there is a third part of this question that is like advanced version. Ansh, Lamba, if we can, okay, and this is like very special, you can just take notes for this. If we can optimize our data while writing it, why do we need to do this optimization after writing the data in the data lake? This is tricky. Just think about it. You know the answer. You know the answer. You just need to be a little bit creative while thinking about it. So the answer is very simple. Let's say you are using this command, okay, and you are not using this command. Sorted. You are only using this command, okay, and your pipeline runs in every hour, okay, in every hour. Now the best case scenario will return only one file in this particular thing. Let's say it has coalesced all the things and generated one file. That is the best case scenario. Make sense? Now just tell me one thing. Even, who is calling me, man? So even after generating only one file in every run, by the end of the day, how many files do I have in my data lake? 24. Very difficult calculation, right? 24. Do I need 24 files? No. So that is why we always use the combination of two. first we optimize the data while writing it, and then we optimize the data after writing the data as well into the data lake. Make sense? Okay. This is a very like third option. Like maybe they will ask you if they want to just test you on your architecture side, on your design side, like why are you using this? If they want to test more on your why part, if you are experienced. Okay. So this is the case. Now you know everything. Make sense? Okay, very good. So now let's try to discuss the senior data engineer interview question. See, if you have clicked on this video, it's my responsibility to make you the master and make you ready for the interviews. Okay. So I'll be just discussing some advanced questions as well. I'm not here to discuss some those childish questions. What is a PySpark? What is this? What is that, bro? So now this question is very interesting and you need to understand this concept carefully. Okay. How does Spark's unified memory manager allocate memory between execution memory and storage memory in this scenario? Now, what is the scenario? I will just talk about it. Don't worry, because I have the scenario ready. I will just demonstrate you live. How does Spark reallocate memory dynamically when execution needs more memory, and what happens to the cached data during this process? This is very, very interesting topic. Okay. And first of all, let's talk about the scenario. Okay. The scenario is very, very simple. You are obviously a data engineer and you are applying some transformations. Makes sense. And initially the job runs fine, no issues at all. But after some time, tasks start slowing down and you are seeing some data spilling to disk. The cached data frames begin getting evicted automatically. What's going on? What's going on? So let me just write it for you. So let's say jobs are slowing down. Cached data frames are evicted. What is the reason behind it? What is going on? So let me just tell you what's going on and how actually Spark Unified Memory Manager allocates, reallocates, deallocates memory while doing everything. Okay. So let's try to understand it. Remember this question. Remember that we have two types of memory, storage memory and execution memory, because we are talking about unified memory. Okay. You need to know this thing first of all. Okay, perfect. So let's try to understand this thing. So let's say we have two memories. Okay. We have two memories. We have execution memory. Okay. We have execution memory. Okay, this is the divider basically. Okay, perfect. This is the divider. So here we have execution memory and here we have storage memory. Make sense? Where we cache our data frames. Make sense? Okay, perfect. Now the thing is, obviously this is 50% allocated and this is also 50% allocated 50-50. But this is soft boundary. This is not a hard boundary. This used to be a hard boundary before Spark 1.6, but after Spark 1.6, we have a soft boundary. And bro, currently we are living in the Spark 4.1 era. So this was happened way before. Okay. So this is a soft boundary. Soft boundary. Okay. Makes sense? Simple. This is a soft boundary. So what happens? So now let's say you have some data. Okay. Now you have some data and now what you want to do? You want to, let's say, store some data frames basically. Okay. Let's do it. So now you want to store some data. Let's say I have this, I have this, I have this, I have this, and I have this execution memory. Perfect. This is running smoothly and my execution memory is full because I have optimized my performance, Spark performance. So I am not overspending my memory. I am not underspending my memory. I am just utilizing 100% of my memory. Make sense? Make sense? Okay, very good. Make sense. Very good. Now during the process, during the code execution, I am also storing some data in my storage memory. Basically, I'm caching some data. Sorted? I am caching some data. So let's say this is my storage memory. And let's pick a different color just to distinguish between these two. So let's say this is my storage memory. Perfect. This is my storage memory. Perfect. Okay. Well, let's draw it here so that you can better understand it. Let's say here. So I have this data. Okay, perfect. Wow. Perfect, just 3. We are not going to fill it because we have some space available. Perfect. This is the ideal situation. Okay, when job was running fine, but suddenly you started seeing that your jobs are slowing down. Now what is happening? Now your execution memory wants more memory. Maybe the size of data increased suddenly. Something happened. Now this execution memory is full. So now what will happen? You have this memory waiting here, like here, like here. Wow. And we cannot allow this. No, this is not allowed at all. This is not allowed at all. So what will happen? This memory, yes, listen to me. This memory will be stored here. Wow. Yes, this is allowed. After Spark, Apache Spark 1.6. Okay, that is why this is called soft boundary. This can be moved here and there. Okay, perfect. Now what will happen? This is also full. Okay, let's say we have some more cache data. So this memory is also full. Now this is like fully done. We cannot do anything else. Okay, now it is full. Okay, makes sense. Now Ansh Lamba, that makes sense. Like when we have some space available, we just occupied the space. Okay, this is like scenario 1. Let me just write it. Scenario 1. Makes sense. This is simple. We took the space. But what if we do not have any space? What if we do not have any space? Because interviewer will ask you all the scenarios, I'm so sure. So let's say this is the case. You have some data here and this is also full. And you have some data in the execution memory waiting to be executed. Okay, this is waiting. Now what will happen? This is challenging. Now, do you know what will happen? See, this is the rule of thumb. Execution memory will always take precedence. So what will happen? You need these 3 blocks. Now what will happen? These 3 blocks will be evicted. Oh, really? Yes. These 3 blocks will be evicted. Based on there's a criteria. Based on LRU method. Okay, it is called LRU, least recently used method. Let's say these blocks are like least recently used, so these will be evicted. So this will look like this. This will look like this. So this will say, okay bro, bye bye. These are evicted and these will come here. Wow, is it allowed? Yes, this is allowed. Okay, this sounds really cool. Now Ansh Lamba, this makes sense, but we have one more criteria. Okay, just ask. Let's say we have now more data. Let's say we have now more data like this. Okay, and these blocks are waiting here. 1, 2, 3 and 4. Now what will happen? Same thing. You know the answer. This will evict the other blocks as well. So this will also be evicted. Wow. Yes, these will also be evicted. Wow, man, literally wow. So that means storage memory has least precedence. Yes. Now Ansh Lamba, if we have, let's say, more data, let's say this is sorted because this was saved. Let's say we have more data. Let's say 1, 2, 3. So this will spill the data to the disk. Because now there are like no chances of doing anything. So now this data will be spill because we do not have any memory left. Spill to disk. Make sense? So that's how it will work. Now Ansh Lamba, is the opposite true? What do you mean is the opposite true? Let's say we want to evict some data when we have it here. No, the reverse is not true. Storage memory can never evict the execution memory because storage memory has no rights, has no power to evict anything. Only execution memory can evict the storage memory. Makes sense? I have discussed all the scenarios and I hope that it will help you a lot because this is an advanced or basically senior data engineer question, but you should know about it because currently there is no senior junior. It's all about a data engineer position. Competition is very, very high. So yeah, this was all about this question. And I hope this has given you a clear picture how it works, right? Okay, let's see what do we have in our next question. So now let's discuss this question. And this question is like obviously technical. This would require coding as well. And do not need to worry, we will cover everything with detail. Okay. So now the question says your team receives event data as files landing continuously in the cloud storage. Okay. Okay. The source team sometimes adds new columns or changes the schema without prior notice. And you know what? That is the best scenario because this is the scenario in the real-time world. They just change the columns without any prior notice. Okay. So that is a real-time scenario. You need to process these files in near real time and load them into a Delta table without breaking the pipeline. Whoa. How would you design the streaming solution to handle schema changes safely? What Spark Databricks features would you use? This is a tricky question. Let me be very honest. Okay. Second thing, this is more of development plus design question because there are so many approaches that you can follow. But they have specifically mentioned what Spark/Databricks features would you use. So now if you are coming from non-Databricks background and you are just sitting in the Databricks interviews and they are just mentioning this thing, they expect you to use the Databricks features in order to handle this instead of just using open source Apache Spark features. Now a random, you can say a user, okay, or you can say not a user, basically anyone, let's say a data engineer sitting in the interviews, okay, the person will say, bro, if it is a real-time data, I will use Spark structured streaming. Make sense? It makes sense, right? But you know what? They do not want to hear this thing. Why? Because you are sitting in the Databricks interviews or basically sitting in the interviews where they use Databricks technology. Yes, you can mention Spark structured streaming. It's not wrong. Technically it is right. But after mentioning Spark structured streaming, they want to hear something called as autoloader. If you are not familiar with autoloader, don't worry. I will just make you understand. That's why I just told you, do not need to worry. I will just mention everything. Autoloader. They want to hear this. This is the, you can say, the moment where they will feel like, wow, this person knows exactly what we need. This person is knowledgeable enough to handle our situation. This is the scenario. And trust me, this is the scenario. They test you like this. Make sense? Autoloader. So they want to listen this part, autoloader. Now, what is autoloader and what is the difference between this Spark structured streaming and autoloader? Basically, autoloader is built on top of Spark structured streaming. Yes, the core thing is still Spark structured streaming, but it is much more optimized. It is a kind of managed layer that is built on top of Spark structured streaming that handles schema failures, that handles all the triggers and so many other things. You can even pass schema hints, and there are so many things that autoloader will handle automatically. You need to define any kind of thing to manage anything. So it will basically act as a manager under the hood for Spark structured streaming, because obviously Spark structured streaming is the backbone. I'm not denying that, but autoloader is the smarter way to use Spark structured streaming, and I personally love this feature. Yes, it is very, very good. Now, this autoloader is not very easy to understand. Okay, there are so many things in order to understand autoloader. First of all, let me just tell you how it works. So let's say you have this source. Okay, let's say you have this source. Let's say this is the source, and here you have some files. It can be any file. Let's say CSV file, any file. Let's say Parquet files, JSON files, CSV file, whatever. Okay, let's say this file. Makes sense. So let's say on day one you received this file in your source. Okay, Now you are using something called as autoloader to process this. Do you know what will happen? It will behave similar to Spark structure streaming. This will read this data. Make sense? This will read this data. Okay. Now, after reading this file, autoloader will write this data to the destination. Yes. Destination. Perfect. Now what will happen? This file will be written here. Perfect. Simple. Yes. Without any kind of tricky things. Okay. Simple. Now on next day, we got this file. Let's say we got this file, a new file. Let's say this. Okay. Let's say this. Now on next day, this file will be processed and that's it. This will not touch this file. Why? Because of a special folder called checkpoint location. Checkpoint location, which will be managed by obviously autoloader. This is called checkpoint. Now, if you are familiar with Spark structure streaming, you can ask this question, Ansh, Lamba, do you know what? We already have checkpoint location in our you can say Spark structured streaming as well. So what's new in that? So very good question. Nothing is new, but the great thing is you do not need to manage this checkpoint location. It will automatically manage it. Very good. And what is the main purpose of checkpoint? The main purpose of checkpoint is idempotency. That means exactly once. That means the file which is already processed will not be processed after that. See, this file will not be processed if it is processed. So only this file will be processed. Very good. Makes sense. Now let's imagine that this file has some new columns in the source. How it will handle that? Here comes the magic of autoloader. Here comes what? Here comes the magic of autoloader. So it also manages one more folder. Okay. It manages one more folder. It's called schema location. Okay. It's called schema location. And this is not there in the Spark structured streaming, by the way, if you do not know. Okay. So this is called schema location. So now the schema location will capture the schema of the data. Okay. Now, if this file has a different schema, it will first get updated here in the schema location. Okay. It will first get updated here. Then it will go to the autoloader and then it will write the data with the new schema. Now the tricky question that interviewer can ask, the interviewer will say, because this is very tricky, interviewer will say, hey, this file is processed. Okay, this file is processed and this file is stored in the destination. Perfect. Now on the second day, this is a new file with some new columns. Makes sense. Now, what is the flow of execution? How it will happen? Okay, let me just tell you how it will happen. And this is very important. Okay, just listen to me carefully. This file in the source, perfect. This file will be traveled into the autoloader. Perfect. This file schema will be stored here in the schema location. Make sense? Okay. Schema is stored in the schema location. Let me just draw it for you. Okay, perfect. So this schema will be stored here in the schema location. Make sense? Perfect. And you know what? This is the main part. This will be cached as well. Wow. This will be cached as well. Okay, makes sense. And now this schema location will enter here and this will provide the information here that, hey, you can just pass the information to the autoloader and then it will write the data to the destination. Perfect. Now on the second day, we have a new file with new schema. Okay. It will first go to schema location and it will assume that the schema is not changed. It will assume because this schema is cached. So it will go here and it will not change anything. it will go to autoloader and it will fail. It will not actually fail, but it will throw the error that schema is changed. Then you do not need to change any code. You just need to rerun your code that I will just show you. Don't worry. You just need to rerun your code in the autoloader. Once you rerun your code in the autoloader, then it will change the schema. Then this schema will be changed from here. So this schema will be updated, like all the new columns, if it has added some columns. So all the new columns will be cached again, but this will be new schema. Makes sense? This is the flow. This is the flow. This is like senior data engineer question. But these are the questions that they are asking right now because the competition is very, very high. But you do not need to worry. You are on this channel, so you are good. And in order to validate my statement, I will just want you to just go and check the documentation as well, official documentation, because that is the source of truth. And I can just bring it right here. I can simply say autoloader Databricks. Perfect. Let's see what is written here. Perfect. Schema inference. Where is schema inference? Schema evolution. Okay, perfect. Configure schema inference. Syntax, we already know syntax. How does autoloader schema inference work? To infer the schema, when first reading data, autoloader samples the first 50 gig or 1000 files that it discovers to fetch the schema. Whichever limit is crossed first, that is fine. Autoloader stores the information in the directory called schemas, which is called your schema location. Okay, at the configured called schema location. Perfect. To track the schema changes to input data over time. Perfect. Now, by default, autoloader schema inference seeks to avoid schema evolutions issues due to type mismatches for formats that do not encode data types, JSON, CSV, whatever. So autoloader just samples a subset of files. That's it. Okay. Now you will read this thing. How does autoloader schema evolution work? Like once one file is there, now comes the second file with new schema. Now just read it carefully. Autoloader detects the addition of new columns as it processes your data. First, it will process your data, then it will get to know, hey, we have some new columns. When autoloader detects a new column, okay, the stream stops. Stream stops with an unknown file or basically field exception. It will stop the stream. Now, even before your stream throws this error, autoloader performs schema inference on the latest micro batch of the data and updates the schema location with the latest schema by merging new columns to the end of the schema. The data types of existing columns remain unchanged. What does it mean? So what will happen? It will throw the error, obviously. But do you know when? First, it will go to the schema location. Every time it will first go to the schema location as per the diagram. Just see. Before going to autoloader, it will go to schema location. It will update it. Make sense? Once it has updated the schema, now this schema is changed, obviously, because this is schema location. Now this caching happens here as well, because this is just processing the data. And you can even remove caching here because this will simply remove the thing. So caching is done here or here as well, but here caching is not very important because it will update it immediately. Now this file will go to the schema location and it will change the schema immediately. That is sorted. After the schema location is changed, it will go to the autoloader and this schema is also cached here and it was never refreshed. Then it throws the error called where's my Google Chrome? Here. Then it throws the error called unknown field exception because it doesn't know about that field because it is just using the cached schema. That's it. Now we restart our stream and that's it. It works fine. Make sense? That's what exactly it is written here. Before your stream throws this error, autoloader has already performed schema inference on the latest micro batch of data and updates the schema location. That means our schema location is updated by adding or merging new columns to the end of the schema. But that engine autoloader is using cached schema. That is why it is not updated. Make sense? So now let me tell you Autoloader is so good that it gives you some options as well to configure your schema evolution. What does it mean? So basically, it will not simply add the columns. That is the default behavior, by the way. If you get some new columns, it will simply add it to the delta table, and that's fine. But rescue is a very good approach if you do not want to change the schema in the end table. So if you just read about it, add new columns. If you say add new column, stream fails, because stream is not actually failed, it just stops, so that you can rerun it, so that you can just update the cached schema. Perfect. So that it can simply add the new columns. Simple. See, existing column do not evolve data types. Simple. But rescue is very, very good. I love rescue because schema is never evolved and stream does not fail due to schema changes. All new columns are recorded in the rescue data column. What does it mean? So whenever we use autoloader, it creates a special column called rescue. Okay. And what it will do, if you pick this mode in the autoloader, and by the way, bro, all these small portions of the topic are very important for interviews. Those surface level questions are not very much relevant. These detailed, I would say, questions are the questions that will be there in the interview. So do not feel like these are not relevant. Okay. So rescue means you have a special schema, basically special column in your schema, in which it will store all the new columns in the form of key value pairs. Let's say you have a new column. It will not create a new column immediately. No, it will put that column under this column, rescue. Or let's say you have two more columns. No worries, it will put two more columns in the column called rescue. So the schema is not actually changing here, but the good thing is data is being captured here for each column. What is the advantage of it? Let's say if you want to use that new columns in the future, you can just simply fetch that data using rescue. If you do not want to do that, you can simply skip it. No worries at all. Simple. I personally love rescue, but by default behavior is add new columns, which means it will simply add the columns to the delta table. Then we have two more modes, which is fail on new columns. It will simply fail the stream and it will not run at any cost, because you do not want to run your stream if you have any new schema. And this is a kind of stream that should be there in the critical workflows where you cannot expect any schema changes, right? Then none means like none does not evolve the schema, new columns are ignored, data is not rescued. That means it will simply say, hey, you have new columns, I don't care, simply skip those. Do not record, do not store, nothing, just ignore. Okay. Make sense? Okay, let's try to see this. And now you will be saying like how we can just do this, because obviously in the coding round as well, they can just ask you to write the code, and we will just looking at the code as well. Don't worry. For that, we'll be using Databricks free edition. And if you do not know about Databricks free edition, Databricks provides you free edition so that you can just code, you can learn, you can practice Databricks. And in order to do that, you can simply go to your browser. Let me just show you that. Simply go to your browser and simply search Databricks free edition. Let me bring it here. Databricks free edition and search, and click on try Databricks for free. And I think you should have your Databricks free edition because Databricks is so popular, and you do not need to do anything here. Simply click here, get free edition instead. And now you need to simply pick your Google account, whichever Google account you are using, and that's it. If you are using it for first time, obviously you need to pick it. Otherwise, click on login. Simple. See, I already have this. So let me just log in quickly. So I have selected my account, and let me just pick this one. And this will open my Databricks workspace. And you can ignore my already existing stuff if I have something, because I do a lot of stuff in Databricks. So, oh yeah. Where is my video? Where is my video? Put my video here. Databricks, are you listening to this video? Just go through my channel. I love Databricks so much. Why my video is not there here, bro? What's wrong, bro? Just kidding. So this is the Databricks workspace, and personally I love Databricks, man. So this is the Databricks workspace, and obviously I expect some basic understanding of Databricks. That's why you're sitting in the Databricks interviews. That is common sense, but yeah. So now what we're gonna do, we can just start working with our autoloader. Make sense? Okay. Now you'll be saying, where's the data? There are so many options that we can just use for data. We can upload our own data as well. We can browse public data sets as well. We can say connect to 50 plus data sources as well. There are so many options. Make sense? Okay. Before doing that, let me just show you one thing. Let me just show you the code for autoloader that you can, so that you can just see it. Simply search autoloader Databricks schema evolution. Perfect. And this one. Okay, perfect. So this is the code for schema evolution, and here we will be using some files. It can be any file, it can be CSV file, it can be Parquet file, it can be JSON file, any file. Okay, we'll be using CSV file, don't worry, but yeah. And here you can see schema location directory keeps whatever. I will just show you everything in the code, don't need to worry. And for this thing, we will be using volumes. Make sense? Volumes. And I expect that you will have some understanding of volumes. Okay, and don't worry, I have an interview question for volumes as well. Okay, but yeah, you should know about volumes, like what are volumes in Databricks. So we'll be using volumes in the for the data sets. We can browse public data sets as well, but I'll be using files because I want to show you how schema inference work. Okay, so let me just click on upload data, and here if you click on upload data, they will just ask you drop one or more files. Basically they will ask you to create some volumes before dropping the data. So what you can do, go to first of all workspace. Okay, because you need to have something ready. You can ignore this thing I told you because I just create so much of stuff. So let's create a new folder, and let's say Databricks PySpark interview. And don't worry, I will provide this, all the notebooks that we are using here in the GitHub repo, so that you can just download and enjoy. Make sense? Okay. So now let me just upload the CSV file, and this is where I will upload it, not here, obviously. Go to catalog first of all. Let's create a new catalog because you would need a catalog to do your stuff. I have so much of catalogs. I will delete it, but let's create a new one. So let's say create a catalog, and let's name it as, let's say, interview catalog. Simple. Okay, click on create and configure catalog. We do not need to configure, by the way, because only I am the one using it. So I can simply say next and save. Perfect. Catalog is created. So this is the catalog that we'll be using for our all the code examples. Perfect. Now let's create a schema as well. Create a schema. Call it as source. Perfect. Now within the source schema, expand it. Okay, now let's click on create and then click on volume, because we'll be creating a volume. Okay, the volume name will be source volume. Okay, or let's say volume, my volume. Simple. Or let's say Ansh volume. Perfect. Ansh volume. Simple. And this is a managed volume. Obviously do not pick external volume because you do not have access to the cloud. Like obviously this is like linked to cloud, but you do not have access to cloud. So this is the catalog name, this is the schema name. Make sure it is the same. Okay, then create, and perfect, our volume is created. Very good. Now I want to upload the data into this volume. Make sense? And before that, I can just show you how you can just upload it. You can simply say upload to this volume, and now you can just add some folders, because I do not want to directly upload the data in the Ansh volume. I want to create a folder within that. I will call it as, let's say, source. Simple. Source and then slash. Simple. Very good. Now I can click on browse. Make sense? So I have two files. First of all, I will upload my first file, orders day one, which is like a kind of day one orders. Okay, like you can say my day one sales, or you can say sales day one, whatever. Sales one, sales one, it's fine. Okay, so this is my file, and let me just drag it here. So sales1.csv, that means sales on day one. Okay, upload it. Perfect. So I have this data in the source. Now let's try to build the autoloader based on this. So how I can just do that? Go to home, Databricks, put my video, bro. So go to workspace and go to Databricks PySpark interview and click on create and then notebook. So now what we can do, we can By the way, I need some more space. Perfect. And you can click on this catalog button so that you can see all the catalogs. And this is the catalog for this course. This is the source. Perfect. This is my volume. You can even expand it. You can see all the folders. Perfect. Now what I will do, let me first of all rename it. Perfect. Now what I will do, this notebook is connected to serverless. Very good. Now I want to write my code, right? I want to write my code. So how I can just write the code? Because first of all, I need to read this data using autoloader. So I'll simply say df equals spark dot read stream. Why read stream? Because this is a Spark structured streaming, right? Then I will say format. Now what is the format of the file? You will say CSV. It is not CSV. It is called cloud files. Okay. This is a special type of format that we use in the autoloader. Now, then we need to say dot options. Now what kind of options we need to define? We need to define now the file format. So the file format is CSV. Make sense? Very good. Now I will say dot option cloud files dot schema location. Remember, I told you that autoloader saves schema location. Very good. You remember that, right? Very good. So now what will be the schema location in my case? So let me just tell you what will be the schema location. Go to files, or not even go to files, go to this catalog, go to this source, go to this Ansh volume. So I have this source folder, and you know what? We always try to create a folder in the destination to track all the changes, or basically for the checkpointing. Remember checkpoint location as well? Very good. Now what I will do, I will create another folder here in my, you can say, volume. I will say destination. Okay. Destination. Perfect. Now within this destination, I will create that folder called checkpoint. Make sense? Checkpoint. So I will say, now you will say, Ansh Lamba, what is the location of this? It is very simple. You do not need to remember. So I will first of all write dot option cloud files dot schema location. And now comes the part. You do not need to remember it, but the format is very, very simple because we are using volume. So I'll simply say slash volumes. And then I can just define what is the volume folder name basically. So in order to do this, you need to define all the things: catalog, schema, and then volume, and then your folder name. So I will simply say interview catalog. Then I will define my schema, which is source. Then I will define Ansh volume. And then I will define the folder within that, which is destination. And within that, I want to create checkpoint, right? This is the way to do it. Now you do not need to remember this format because nowadays we have amazing thing by Databricks. You can simply click on this 2 arrows and it will insert that same thing here. Perfect. Wow. And we just need to define the folder we want to create within this. It is called checkpoint. Perfect. Now, if this is also done, then we can simply say dot option. Now here we need to define that what kind of autoloader mode we want. Okay. So I'll simply say schema evolution, or basically cloud files dot cloud files dot add new columns, or schema evolution. I think schema evolution mode. And by default it is this, add new columns by default. Remember, if I just, where is my edge? Okay, here's my edge. So if I just show you, see, by default it is this one. It is not even like mentioning it here because that is a default thing. See, they are not mentioning it how you can just define it, but I just showed you here when I was explaining this. See, so you define this thing with this property, cloud files dot schema evolution mode, and by default it is add new columns, but I will choose rescue. Simple. Rescue. Simple. Okay, make sense? Okay, so now I can simply say rescue because I want to show you the power of rescue, and I love rescue. Okay, this is rescue. And then simply we need to say dot load, and that's it. And load is this one, right? In our source folder, This is the load. Load is basically the path. Perfect. Let's see if this runs fine. Okay. Data streamer object has no attribute format. Obviously, what is format? I know you have a great accent, Ansh Lamba, format, but it is called FORMAT, format. So now let's see if it runs fine. Okay, this will run fine. I hope so. Now what I will do, I will just simply write this data to the destination. So meanwhile it is running, let me just write my code. So I will simply say df dot write stream dot format, and I want to save it as in the delta format. I love delta. Then I can say dot option, and here I will simply say checkpoint location, right? Checkpoint location will be this one, the same one. See, the location here is this one, checkpoint, and here as well it is the same one. Why? Because we want to keep the checkpoint and schema location under one parent folder. That is the ideal real-time approach. It's not hard and fast rule, you can pick any location, but it is my recommendation. Okay, good. Then you can say dot start, and that's it. You can simply say start this destination, right? So it will start writing this data. Trigger, obviously we need to pass a trigger as well. So what kind of trigger we will be just using? I will use dot option. Trigger once equals to true. I think that is more better approach. Trigger once equals true. If you do not about once equals true, this will run everything and it will stop after running it. It will not keep on running our cluster. Two, obviously we do not want to waste our resources. I know Databricks is providing us everything is for free, but do not waste its resources. Okay. So it is saying stream initializing. So it has started writing our data. As you can see it here, the graph is here, and see, this is our data. If I open the destination, I should see my data written in the perfect, in the delta log. Perfect, perfect, perfect. This is amazing. Now, do you know what I'm going to do? I'm going to play with it, because if you will read the data, you will see it like this. Let me just show you. If you, let's say, read this data, and I think I just made a small mistake. I should have written it data instead of directly in destination. So let me just change it, because I should not do it like this, because it can just create a conflict with checkpoint. So let me just delete it. Delete directory, and I can delete this file as well. Where is that thing? And this is a very good test for our delete volume file. Perfect. So now, do you know what? If I just restart this thing, let's say I want to just reprocess this. So do you know what will happen? Let's see. What's your answer? Just tell me in just 3 seconds. Let me just tell you what will happen. It will not do anything. Why? Idempotency. That means, and this is again your follow-up question of interview. This is called idempotency. That means your data that you have written is only processed once. It will not be processed multiple times. Make sense? It is not going to process multiple times because idempotency. So if you want to reprocess everything, you need to delete your checkpoint as well, because the checkpoint is there. So that means it will not reprocess everything. But now if you do it, it will write the data. Are you sure? Bro, trust me. Let me just reprocess it. Let's see. Because now Spark doesn't know, autoloader doesn't know if you have processed the data or not. So because you deleted the checkpoint location, right? So now see, it will write the data. I'm so sure. What? Destination? Are you sure? And what's wrong? Okay, makes sense, because we didn't just created this thing. So let me just rerun this. Let's wait and let's just refresh. How to refresh? Okay, let me just refresh the catalog. Oh, here's the refresh button. Okay, let's check. See, told you. Data is there, checkpoint is there. Very good. Now let's, or see, checkpoint location has all the things. See, it has commits, it has offsets, it has sources. These things are created. They are using this thing which is called destination checkpoint, and this schemas folder is created using schema location. So these 3 folders are for your this thing which is checkpoint for destination, and this thing is for schema location. I told you that this is not just a like surface level interview video. I am gonna just discuss so many follow-up questions as well if I'm just discussing the parent level question. So these are your follow-up questions. These 3 folders will be created when you will be creating checkpoint location using this, and this schema's location, basically this folder will be created using this schema location. So you have total 4 folders. Remember this thing, bro. Take notes of every information. Now if I just try to query this data, let's say I write select asterisk from, and if I just try to query this data, let's say delta dot backticks, and if I try to pass this location, let's say like this, let's see what do we get. So here you will see the column called rescue. See, rescue data. Currently it is null because there are no changes, but hold on, let me just add one more file which has a new column. So currently we have these columns 1 2 3 4 5 6 in my new file, in my sales2 file. So sales2 file, let me just upload it here. If I add it in the source Ansh volume, and I will add it in my source, perfect. So let me just drop it here, sales2, where it is uploaded. Let me just upload it like this, upload to volume, and let me just drop it here now. Perfect. Now if I upload it here, do you know what? This sales2 file has one more extra column called cancelled flag. Okay. So now what will happen? It will capture that column information in this particular column called rescue data, and it will not stop or basically fail the stream. Let me just show you. So let me just run this stream for one more time. Okay. Fingers crossed. Let's see what happens. This should not fail the stream because the schema is intact using rescue data. Now let me just query this file for one more time. Let's see what happens. Boom. Now see, these are my new records, basically the new files, and this time my pipeline didn't fail because all the new data, all the new columns are captured in this column called rescued data, and this column is called cancelled flag. The best use case is this one. Now you know all the parent level questions regarding autoloader. You know all the you can say inner small follow-up questions as well. So now you know everything about autoloader. If interviewer asks you anything, bro, if you didn't answer that question, do not talk to me, okay? Because I have explained everything in detail with code, with graphics, with live illustration, with documentation, everything. And why I have discussed this thing in so much detail? Because this is the question that is being asked in every interview right now. That's why I thought of just covering it in detail. Make sense? Very good. Now let's jump on our next question. So let's talk about this question, and this question is very, very important. And I would say with the latest upgrades in Databricks, this becomes even more important because this will test your updated knowledge in Databricks. Obviously, autoloader was also updated, like one of the kind of updated knowledge, but this is like architecture level. And now you will say, Ansh, Lamba, do we need to know all of these things as well? Obviously. I know you are applying for a data engineer role, but having the knowledge about architecture is something that they expect from you as well. They're not asking you to build the architecture, but you need to understand the things, right? Okay, let's talk about it. So your team is building a data platform on Databricks. Ooh, very good. Daily ETL jobs runs once a day and finish in 20-30 minutes. Cool. Ad hoc analysis is done by data engineers and analysts throughout the day. Cool. Cost optimization and cluster stability are important. Yes. How would the architecture differ? Important. How would the architecture differ if you use a serverless compute versus all-purpose compute for this setup? Or you can say job compute. Basically, serverless compute versus traditional compute. Because serverless compute is something very, very new, which is the latest type of compute that we have in Databricks. And Databricks asks you to, hey, use serverless compute, use serverless compute, use serverless compute. Okay, but what will be the difference in architecture? Which workloads would you place on each and why? Wow. So for in order to answer this question, let me just tell you like what's the best and simplest and quickest way. Okay, so first of all, let's talk about the architecture when we do not have the serverless approach, basically serverless compute, when you do not have this. Make sense? So let's say what you are trying to do, you are a user. Okay, you are a user and I would need, let's say, data lake as well. Let's pick S3 buckets. Okay, perfect. We will use it. Or let's say ADLS. Perfect. Make sense? Okay, so let's say you are a user and you have access to Databricks workspace. Make sense? You have access to Databricks workspace. Okay, the same portal that we just recently opened. Make sense? Okay, so here you have obviously some stuff. For example, you have here web portal where you just do all the stuff. Web portal, you have here web application, Unity catalog, queries, like all those front end stuff, right? So in short, I have just written web portal, but it contains all of those things. Make sense? Good. Let's put a color here. Yep, perfect. Web portal. Okay, this is a web portal. Now, what will happen? This is the web portal. Now, this Databricks workspace doesn't have any kind of storage, right? It doesn't have any kind of storage. Makes sense. It doesn't have any kind of storage. So what happens? So when it doesn't have any kind of storage, obviously this will be linked to the what? Linked to the kind of cloud. Now this cloud can be anything. Yes, this cloud can be anything. So now this cloud can be anything. So that means we will be storing our data in the cloud. Make sense? Good. This cloud can be, let's say, ADLS Gen 2, S3 bucket, or let's not make GCP people sad. Let me just bring GCS as well. Google Cloud Storage. Okay. So let's say they are as well. So now this thing will be linked to this thing. Okay. Makes sense. This is cloud. This can be any cloud, literally any cloud. Okay. Now this link is established with this one, obviously. Okay. This is my cloud. Because in the cloud, we have all the things, all the storage, all the data lakes. Okay, perfect. And let me just shrink it. Okay, perfect. So this is my Databricks workspace. So now what will happen? This Databricks workspace is connected to this. Okay. Now, if let's say you want to store some data, you can store it, but where will the processing unit will be stored? You are using all-purpose computer, basically job computer, basically the traditional compute, right? So traditional compute uses virtual machines, which are hosted on your cloud server. Make sense? So all the virtual servers, or basically machines, do we have machines, compute? Yep, let's use this one. So let's say this is my cluster. Okay, so this cluster will reside in the cloud and I will manage that. Why? Because I am hosting it in my cloud. Make sense? Make sense. Okay, now this is the traditional approach. Now if we want to do everything same in the serverless compute, let's imagine that we want to do everything in the serverless compute. So now what will happen? Nothing will change majorly. Okay, nothing will change majorly. The only change will be this Databricks workspace will use the serverless compute. And now when I'm saying that this will use serverless compute, that means this cluster will reside here instead of using your hosted VMs. What is the advantage of it? The biggest advantage is you do not need to manage the virtual machines at all. You do not. Wow. Yes. That is why you see that serverless compute starts very, very quickly, because it is hosted on the Databricks side. You do not need to manage on your side. But yes, Storage will still remain the same because Databricks does not store your data. It will be stored in your favorite cloud storage account. This is a difference. Make sense? So this is traditional approach. This is with serverless compute. Okay, I can also write, let's say, serverless compute. That's it. Make sense? And this is your traditional cluster. This is the thing. This is the thing. Perfect, simple, sorted. Okay, let's see our next question. So let's talk about question number 6. So this question says you are working as a data engineer for an e-commerce company, or let's say you are working for a company whose client is an e-commerce company. The business team tracks a daily revenue KPI in Databricks using a delta table. Okay. If daily revenue drops by more than 10% compared to the previous day, the business stakeholders should get an alert immediately on email or Slack. How would you design and implement alerts in Databricks to notify the respective stakeholders? This is a very, very important question and you need to understand this. And the implementation is very easy, but I hope that you have got the understanding like what we are trying to do. Let's say you are a data engineer. Okay. You are a data engineer and you have developed something. Let's say you have some delta tables that you are just managing. Make sense? So many delta tables. Do we have tables? Yes. Let's say you have this table, generic table. Make sense? Now in this generic table, or let's say this is like sales table. Okay. Now if the sales table, now the sales table shows you that the KPI is maybe reduced by 10%. It can be any logic, by the way. It can be any logic, literally any logic. If the sale is dropped by 10%, you need to notify who? The respective stakeholders. Let's say these are your stakeholders, managers, whatever. You need to notify them. Make sense? Make sense? Okay. You need to notify only and only if this KPI is declined by 10% only. Otherwise, it's fine. So how you can just develop the alerts in Databricks? Let's try to focus on that thing. Okay. So let me just bring my Databricks screen. Where is my Databricks screen? Okay, perfect. So here is my Databricks screen. So let me just take you to the area. Just click here and just click on something called as SQL. Expand it and just go to alerts. So we have an option to create an alert in Databricks. How you can just create an alert? It's very, very simple, but not very, very simple. Let me just tell you how you can just create an alert. For that, you have to have a table. Now, where's the table? Now we do not have any kind of table. Let's quickly create a table because we just have the delta lake. That's it. We do not have any table. So let's create a table actually. And let's say, go to SQL editor. Okay. Or you can even go to queries. It's fine. It is my previous query. Just ignore. Let's create a new query. Okay. Let's create a new query. Perfect. And you can pick your interview catalog, source schema, and you can also change it from here. Just pick interview catalog and then source schema. Do we have source schema? No, we have this. Okay, it's fine. We can just pick it after that. Yeah, now we have source. Perfect. So let me just quickly create a demo table. Let's say create table. Code assistance is inactive. Why? Okay, let me just start it. You need to start your SQL warehouse. SQL editor now supports sessions. You can now define variables or create temporary views in one statement and reuse in, oh wow, very good. So this is up and running, serverless compute. So let me just create a table and make sure this catalog and schema is selected. Okay. So create table and table name will be very, very simple. Let's say sales. And then let's define the sale ID. And ID is ent. And product revenue, that's it. Okay, and that should be good. Also, let's insert some data. Okay, shirts, pants, And let's insert some more data. Shoes. Okay, that's it. Let's run it because we just want to see the values. Make sense? Okay. So now we have ID, we have product name, and we have the revenue as well. Okay. So now it will create the table for me. Just a demo table, not a big deal because we are not mastering how to create a table. Obviously, you know how to create a table, but we are just mastering how to create the alerts. So let's go to alerts now. And there are two options: alerts preview, alerts legacy. Legacy alerts are very much similar to the new one, but I would recommend you to just use the alerts, which are the new way of creating alerts. I love the newer way. Legacy is also good, but the newer version is better. Let's create a new one, create alert. And in order to create an alert, this will just show you so many things. Do not overwhelmed by looking at this. It's very simple. First of all, they will ask you write and run a query so that you can just view some results. Make sense? Then you can just put some conditions here. Then you can just schedule the alert. Don't worry, I will just show you step by step. So I will write my query. I will simply say select sum of revenue. Okay, sum of revenue, and I will say, let's say total sales, total revenue from the table name. Table name is, I think, interviews catalog dot source dot sales. Perfect. So I want to just find this. Let me just say run all. So what it will do, it will give me total revenue. Let's say my condition says, obviously it is a hypothetical situation. So I want to create an alert. Let's say if my total revenue exceeds $1,000, or let's say it is reduced to 800, I want to receive the alerts. Okay. So I will simply go to condition. I will say first row, select column, total revenue and static value. You can also put dynamic value, sum, whatever, but I'm already calculating sum, so I do not need to put dynamic value. I will say 1,000. Okay. And I want greater than or basically less than. If my total revenue, this column is this, if this total revenue, or let's say not just total, like it can be anything. Let's say KPI, just to make it more real. Let me run it for one more time. Perfect. KPI. So this will become KPI. So let's say if this KPI is less than 1,000, okay, and KPI can be anything. If this KPI is less than 1,000, I want to get the notification. Perfect. And I can simply test the connection, test the condition basically. Let me just test it. And okay. Alert will not trigger based on the current data. Why? Because it is not less than 1,000. If it is less than 1,000, then it will say trigger. But currently it is saying okay. Make sense? Good. Now notify. Now you need to add the users. Now I can simply click here and I will see Ansh Lamba because my email ID is already added in the Databricks. If it is not added in your case, you can go here in the settings and just go to identity and access. And I think go to notifications and then you can say manage, and here you can add your destination, that is your email ID. Make sense? That's how you can add the email ID in your Databricks. Once it is there, you can simply say notify Ansh Lamba and you just need to hit the trigger once. Make sense? And you can say Ansh Lamba is there. Okay. View alert. You can also say run alert, but I don't want to run alert, but I will simply say view alert. If I want to schedule it, I can schedule it so that it will be just checking, let's say every hour, every day, every night, whatever. The frequency is not our concern. Make sense? So that's how you can schedule any alert based on the SQL query. And this SQL query is your responsibility, that how you define that query. Again, this is your SQL skills, and that is why we always say Python and SQL are your bread and butter, and you need to know all of those things. Make sense? Okay, so that is all about the alerts and how you can just notify the stakeholders based on this thing. Very good. So bro, now question number 8. This question is very relevant in today's era. Okay, now let me just tell you what's that. Your finance and business teams use Databricks for analysis, but they are not comfortable editing SQL queries. Obviously, they are business teams. They are not technical teams. But they often ask you to run the same SQL logic again and again just with different dates, different filters, different countries, whatever. But they do not want to do it because they do not know anything about SQL. Even they know, they are business people, they are afraid of using or editing the code because it can break so many things. So they just call you, hey, Mr., Miss, Mrs. Data Engineer, can you please rerun this logic and give me the reports or give me the data by updating the filter? So now the question is, and before even question, what is the problem here? They do not want you to call again and again. They do not want to call you again and again. Simple. So the question is, how would you design reusable SQL queries in Databricks so that non-technical users can run the analysis by just changing the inputs without touching the core SQL logic? Ansh, Lamba, how it is even possible? Because if we want to change anything in the SQL results, we first need to change the query. And you are saying that how we can build a SQL query so that non-tech people can change it without touching the code. How it is possible? Bro, that is why this is the video for you. Because you need to know there are so many things that are there in the Databricks. Okay, so now I hope that you have understood the requirement. So let's say this is your table and you use a SQL. Make sense? Now there are users who wants to use this table using the same SQL query, but without, or basically no code SQL. What is this no code SQL? Basically they want to just run or basically change the SQL, but they do not want to run this SQL through the code, right? They are business users and you are a data engineer. You are smart, you know SQL, that means you are smart. They are not smart, they are dumb. Just kidding. So data engineer and business users, make sense? So now you can do this in the Databricks. How? Let me just show you. So let me just open my Databricks. This is my Databricks. Now remember, this was our query. Let's say this is the table that you are using. Let's try to go to the query instead of going to alerts. And I think this is the query. Let's open this. Let's open this and let's try to rename it. Let's say reusable query. Make sense? Reusable query. So let's say select asterisk from, again, in order to do all of this you have to use query, okay, not files, queries, because this option is only available in the queries. So I'll simply say select asterisk from sales. Let's try to see it, and I have attached my cluster. Coffee time at 11:33 p.m. the best time to have coffee. Bro, intent is very clear, just to help you guys, that's it. No matter it's 11:33 p.m, whatever, 2 a.m, doesn't matter at all. Just keep going and just want to help you, that's it. So let's say you want to build a SQL query, and obviously here we are building a very simple query, but here we are just trying to learn how we can create reusable query. Now SQL query can be complex, can be easy, that's out of scope. The intent is creating the query which can be reused, right? So let's say your business manager calls you, hey, not like this, obviously they will say, hey, please can you run this thing with this filter. Let's say today they will say, run this query, run your complex SQL query. Here we are using very simple select statement, but imagine you are using a very complex inner subqueries, okay? And then they will say, just change the filter. Now you will say where product equals shoes, right? Then you will run it and you will send this data back to the manager. Very good. Now they will say, hey, can you please change it, and then can you please just make it, let's say, pants. That's how they just ask you to do the work, right? Okay, so you did it. Now every day they're just calling you, blah 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 blah. Now you do not want to do this, or let's say they are also they are also irritated by calling you again and again. So now they want you to build something so that they can also make the changes without touching the SQL code. They don't want to touch this. One quick option is you can create a dashboard for them so that they can just do drag and drop in the filter and they can do the stuff. But be honest, dashboard is too much for this simple SQL query. You cannot build dashboard just performing some analysis, some quick analysis over some basic or complex SQL queries, right? Dashboards are like for dashboards, like dashboards are for like reporting something over data warehouses. This is just a query. So dashboard will be too much. So what you can do, you can leverage something called as parametric queries or parameterized queries. So how you can just do that? So instead of hard coding the values here, you can simply create a parameter here and it starts with colon and then your parameter name, let's say product filter. Make sense? Let me just run this. What will happen? It will give you a box. So now the business user doesn't need to touch this code. Now the business user will come to this query. You will obviously share this query with the business user. Okay. Now business user will not touch anything here. The business user will just put the value that he or she is asking you to change it. The person will say, I want to see the numbers for shoes and run it. And boom, you can see the results. Person will say, I want to change it now, this time for pants, run all, boom. Now the person is not changing anything here. Because see, this is a very simple query. Maybe you are writing 100, 200 lines, 300 lines of code for SQL and there are so many parameters, right? Here I am just demonstrating the concept. There can be, let's say, 10 parameters, 20 parameters. So you do not need to worry at all. You can simply provide this thing to the business and that's it. You are good. How was it? Did you know about it? Did you know about it? No? Don't worry. That's why you're watching this video, right? So that's how you can create reusable queries and your business can, or basically non-tech people can also run the SQL, make the changes in SQL without actually touching the code. Sorted? Very good. So what is our next question, bro? Let me just see. What do we have? Oh, by the way, that was question number 7. Okay. Now we have this question number 8. Coffee. So now it happens. So now this question is very, very interesting. Plus my personal favorite as well. This is, let me be honest. Okay. This is not very technical. This is not very architectural. This is not very design focused. This is a common question that should be that is expected from any data engineer in the today's era. Make sense? Okay. What is this question? And this is more of like admin level question, but this is the question that I am observing in the modern interviews after like obviously talking to the people. And this is like my personal observation as well, because if you will ask me, hey, take an interview of any individual, I will definitely ask this question, because this will obviously give me the idea how well that developer is aware of the Unity catalog concept. So this question says your organization is using multiple Databricks workspaces, dev, test, prod, which is a very common thing. Okay, multiple workspaces. Okay, makes sense. Across different teams, data is stored in a centralized cloud storage account and you want fine-grained access control, table, column, row level, single governance layer across all workspaces, central auditing and lineage. How would you design the architecture using Unity Catalog in a modern Databricks workspace? Explain the key components involved: metastore, catalog, schema, storage, and access control, and how they interact. Very important thing. Very, very important thing. So now, before answering this question, you need to know a very basic thing, which is the Unity Catalog architecture. Now, what is the Unity Catalog architecture? Simple hierarchy. First of all, you have Unity Metastore. Okay, Unity Metastore. This is the highest level of the hierarchy, where usually, and I personally like this hierarchy method as well, where I attach my cloud storage as well. Okay, let's say ADLS. I will attach this at this level. Okay, so I attach this Unity Metastore to the cloud storage as well, because we want to create something called as default storage account, centralized storage account for all the environments. So I will create my data lake at, or basically default data lake at the Unity Metastore level. Now, whenever we have Unity Metastore, then we create our Unity catalogs under the Unity Metastore. Okay, what does it mean? We have Unity Metastore. Okay, we have created different Unity catalogs, and each catalog is in a separate Databricks workspace. Wow, yes. And we need to make sure that those catalogs can interact to each other. Wow, that is the power of Unity catalog. So what we will do, we will create Databricks catalog. Okay, let's say this is dev, this is dev, and this is test, and this is prod. Okay. Ooh. This is prod. Prod. So okay, we have dev, test, and prod. Now do you know what? Each Databricks workspace has its own catalog. It has, let's say, development catalog, sales development catalog, whatever. Test has own catalog, prod has another catalog. But each Databricks workspace is not isolated. No, it can talk to each other because each Databricks workspace is actually connected to the same Metastore. Wow. So can we talk to each other like this? Each, you can say, catalog can talk to each other if we have same Metastore. Yes, they can. That is the power of Unity Metastore. Make sense? They can talk to each other. Now, each Unity catalog is actually connected to the same default storage account. So whatever data will be written here, it will go to this particular storage account. Wow. Yes, that's how they can connect to each other. Now, obviously, within each Databricks workspace, within each Unity catalog, we'll be having tables, functions, whatever. Let's say we have tables, we have delta tables here. Okay, let's say we have delta table here, we have some functions here, we have some functions here, we have some more tables here, whatever, right? So all these things can talk to each other. Why? Because each Unity catalog is connected to the Metastore. This is the high level hierarchy. First of all, Unity Metastore, then Unity catalog, then your objects such as tables, functions, views, whatever. Schema as well, obviously. There will be a layer of schema, which is like very obvious, but still I can just refer it. So we'll be having schema here as well. Schema, let's say schema, let's use this one. So this is a kind of schema. Okay. So we have a schema here as well. Perfect. Makes sense. This is the high level architecture for your requirement, and that's how you should just take care of this thing. Now all the auditing and lineage will be taken care automatically using Unity catalog, and I can just show you right now. If I open my Microsoft Edge, if I go to my these three bars, if I go to catalog, if I pick my catalog, let's say interview catalog, now if I go to catalog explorer, you will see everything: delta sharing, external data, whatever I have, credentials, connection, external metadata. If I go to, let's say, policies, permissions, obviously we have not configured so much because we have just freshly created this thing, but all the things will be here. Everything will be here. If I want to, let's say, find the lineage for this table, I can even go to this table specifically. I can see the lineage. So this is the lineage. This is the upstream, this is the downstream, and that's it. We can also see the graph, but this is the only thing that we have, so there's no actually lineage. But we can see everything under the Catalog Explorer with the power of Unity Catalog. I hope it makes sense. That's how we just work with the Unity Catalog architecture. And this is a new architecture. This is the latest update in the Unity, not Unity, like Databricks workspace. So you should be aware of this. Make sense? Good. So now, this question is very, very important. And this is the question that can be asked obviously in the interviews, and you will see this question everywhere. Everywhere means everywhere. Like literally everywhere, because this is the question that is like literally everywhere, like including so many things that you will be just appearing for, including everything. Okay, Ansh Lamba, stop hyping, just tell us about this question. Okay, your team uses a serverless SQL warehouse for BI dashboards. During business hours, hundreds of users hit the dashboard and queries slow down. At night, usage drops to almost zero. Which compute type would you choose for the SQL warehouse, and how does it scale automatically to handle this pattern? Boom. This is very, very important. And for this particular question, I would love to bring the official documentation. Okay, because I want to show you something. Let me show you Databricks SQL warehouse compute, because basically we have 3 different types of SQL warehouse compute. Let's try to look at it one by one. Compute SQL warehouse, perfect. SQL warehouse types. So if we talk about SQL warehouse, we have 3 major types of SQL warehouses. Number 1 is classic, second is pro, third one is serverless. Okay, what is the difference between 3? Classic means you have more control and you are responsible to, let's say, perform some kind of tuning, some kind of, you can say, auto scaling, not auto scaling, but some kind of tuning. This is like more on your side. That is why you can see that it does not support predictive IO. It does not support intelligent workload management. Okay, X means it supports. It's reverse of it. Now if we talk about pro means it has Photon engine. By the way, what is Photon engine? Photon engine is nothing but just a kind of C++ based query engine that makes your query run faster. Okay, pro means you have Photon engine for sure, and it also supports called as predictive IO. Now what is this predictive IO? Predictive IO is a suite of features for speeding up selective scan operations in SQL queries. Predictive IO can provide a wide range of speedups. For example, just to understand from a layman perspective, this can predict in advance like what will be the workload and what will be the, you can say, query that will be running. Not very much smart, but some kind of predictive indexes are there. Then here comes the best version of it. It is called serverless. If we talk about serverless SQL warehouse, it has all the things: Photon engine, predictive IO, and intelligent workload management called IWM. This is the game-changing thing because this can auto scale more efficiently, because it knows like when we'll be just hitting the SQL warehouse more often and when we will not be. So if you just read the definition, you will get the answer. This is a set of features that enhance the Databricks SQL Serverless ability to process large number of queries quickly and cost effectively using AI powered prediction and dynamic management techniques. Because see, this is using AI under the hood to predict better. So this is the best version available for serverless SQL warehouse. But that's not the end of the question. No, you need to understand how scaling works here, because that is the whole difference. Make sense? Okay. Now if I just go to, let's say, scaling. So here is the scaling thing. How scaling works in SQL warehouse. There are 2 different types of scaling. Okay. One is for scaling in classic and pro SQL warehouse. So whenever you create a classic and pro SQL warehouse, you basically pick a size, cluster size. Here are the size options available: 2x small, extra small, small. What does it mean? Driver instance type is this one, and worker count is just one. XL, basically XS, basically extra small. This is the virtual machine type, and there will be 2 worker counts. Then small, this is the machine, and there are 4 worker counts. So this is the size of the cluster. Make sense? Very good. Now what happens? Let's say you want to auto scale this SQL warehouse. Let's say you have picked this thing. Let's say you have picked medium. Medium means you have, this is the machine size and these are the worker counts, 8. Now do you know what? Let's say you are using this medium cluster, okay, based on your data size, based on your query processing speed. Now what is happening? A lot of data analysts or business people are trying to run SQL queries against your warehouse. Do you know how auto scaling will happen? So here is the auto scaling logic. So for classic and pro warehouse, auto scaling adds clusters. This is the most important word, clusters. This will not add machines. That means it will not say, hey, if you want to auto scale it, just increase the number from 8 to 9 or 8 to 10. No, it will add the entire cluster. That means 8 more worker counts. Wow. Yes. And automatically the same size, because you have picked this medium size, it will add one more cluster of the medium size, and that's it. Make sense? Good. And when it will add it on the estimated time to process all running and queued queries. So let's say if your queries are waiting for 2 to 6 minutes, it will add one cluster. If it is waiting for 6 to 12 minutes, it will add 2 clusters. Then if it is waiting for 16 to 22 minutes, it will add 3 clusters, and so on. Make sense? There is one more rule. Databricks says if you have 10 concurrent queries, that means 10 people are trying to query the same data warehouse at the same time, one cluster is enough. If let's say 10 more people are trying to query the data warehouse at the same time, you need one more cluster. That means it asks you to create one cluster per 10 concurrent queries for the best performance. Make sense? Easy? Very good. Now how auto scaling works in the serverless SQL warehouse. This is different, and this is more, I would say, preferred way, because you do not need to worry about the sizing. You do not need to, like, still you will pick the size. Obviously you will pick, like, let's say small, extra small, medium, but it will auto scale. It will add the cluster with much more efficiency, because it determines the resource available for a single cluster, and the auto scaler adds or remove cluster of the size as needed. And as you know, it uses IWM, intelligent workload management, and can predict better. Make sense? So use the following guidelines to help choose the right size. It says start with a single larger warehouse and let serverless features manage concurrency and performance. Make sense? It is usually more efficient to size down if necessary than to start small and scale up. Make sense? So serverless actually takes care of lot of boilerplate thing, a lot of headache that you will be receiving if you do not use serverless compute. Make sense? Very good. So now that's how you can just pick the right answer, and now you have the right answer for this particular question. And we have discussed about this thing as well, like how you can just do this. Make sense? And I can create 3 different clusters just for you, just for your notes. And one cluster is, do we have cluster? I saw some dots, right? Yeah, let's use this one. So this is my cluster, let's say. So I have classic. Okay. I have classic. I have pro. And I have serverless as well. Make sense? Make sense? Make sense? Make sense? Okay, very good. So let's see our next question. Let's look at this question. This is like AI era question, and once you will see the answer, you're gonna love Databricks. Okay. Your company has a Databricks lakehouse with delta tables for sales, customers, and transactions, whatever. Business users, non-technical, want to ask questions in plain English like, what were the last quarter's top selling products in Canada, India, whatever. They want, basically they are trying to say that they want to access AI chatbot on top of your data. The same way they use ChatGPT, the same way they use any kind of LLM, they want you to build a chatbot in Databricks. Ansh, Lamba, is this a joke? Is this a joke? I know like building chatbot is very important, but is this a joke? Like it takes so much of effort to build a chatbot? Not really, bro. If you have watched my videos about generative AI fundamentals, which is a complete course, and if you have watched another video called RAG masterclass, it's very easy. And if you have not watched those videos, what are you trying, like what are you doing? Have you even heard about those videos? Just go on Google and just say generative AI for data engineers, because see, everyone is talking about everyone is talking about Gen AI. No one is talking about Gen AI for data engineers. Only Ansh Lamba is talking about that. And you can just watch that video as well if you have not watched that video, and simply say Ansh Lamba. Okay, and this is the video for that. I don't know why icon is not coming. So if you click here, if you see this thing, this is the course, complete course for Gen AI, and you can just enjoy this video. This is a complete like masterclass, generative AI full course for beginners. Okay, and I have one more video that you can watch after this. It is called RAG full course that you should watch. Okay, and you will find yourself in a very good place, because see, you need to be competent. But now we are talking about this question. Okay, and now for this question, the good part is we are leveraging Databricks. So with Databricks, we can build any AI chatbot, any, on top of our data. So let's say you have this thing, you have your data. Let's say you have your data, okay, in the delta format, and this is your everything. Okay, this is your data. Now you can build a kind of data agent on top of it. Wow. Yes, you can build a kind of agent, or basically you can say LLM, whatever you want to call. So you can use this LLM, okay, which will be managed by Databricks, and any user can access this thing. And I think this should be the case. See, perfect. Now let's say you are the user, or not you are the user, let's say any business user, non-tech. These are the users. Let's say these are the users. So now they want to do this thing. They want to query your data. So what they can do, they can go to this particular chatbot, AI chatbot, and they can ask their question, okay, in natural language, in simple English, and this will go to this particular data lake, okay, delta lake, and it will return the data back to the user. Wow. Yes, it will return data back to the user using, you can say, this particular data, and everything is managed using Databricks. That is the best part. Everything is managed by Databricks. You do not even need to do anything, and I will just show you. Don't worry at all. Everything is managed with Databricks. This is the architecture. Perfect. See, so cool, so simple. And let me just show you how you can just do that as well. So if you just go to the Databricks, okay, so let's say this is your Databricks workspace, and if you want to enable, we have this data, called sales. Let's say this is your table and you want to enable AI chatbot. You basically want to build an AI chatbot on top of this table. Make sense? What you will do, you will go to Jenny. Jenny is the AI chatbot that is created by Databricks for all of your data. Go to Jenny, and this is my chatbot that I created in October 2025. Let me just delete it, or let's create a new one. Okay, let's create a new one. I will say, and it will ask me to pick the catalog, whatever. I can say this catalog and this schema and this table. Perfect, create. I can pick multiple tables as well, okay? And I can start my warehouse. So do you know what will happen now? Let me just show you what will happen. Now this will turn on my AI chatbot, okay? And it has access to these tables. For now, I just have one table. You can add multiple tables as well. Make sense? Now I can literally ask anything. And not just this, I can even attach more tables, more custom CSV files, PDFs, Excel file, whatever. I can attach anything. I can even pass some instructions that, hey, you need to just do this, you need to just do that, some SQL execution, some text, some joins, whatever. I can basically fine tune it. Not technically fine tune, but I can give some instructions. Fine tuning in the form of prompts, basically. You can call it as like this. Okay. Make sense? Okay. So now if I just go and ask this question, let's say, hey bro, what is the total sales we made? Or let's say, what is the total sales for the organization? Make sense? Simple English. Okay. Let's see if it is able to answer that question. So it is doing all of the stuff. It is running all the SQL queries under the hood. Perfect. It has done the work. See, I have built AI chatbot on top of it like this. Boom. Boom. If you have data inside Databricks, AI chatbot is already there for you. You do not need to build from scratch. Plus, it is not just a common or basic chatbot. You can simply pass literally anything. Your CSV files. See, you can attach anything if you want to. You can attach anything. This is amazing. So now I hope you know the answer. Very good. So now we're gonna talk about some coding questions for PySpark. And for that, yes, you need to be pro in PySpark coding as well. So I'll be just discussing some complex or basically modern or basically latest PySpark coding question that you can expect. Okay. Again, PySpark coding question is like, I would expect you to obviously master it. Okay. But still in this particular video as well, we will discuss some popular PySpark coding question. And once you master those PySpark coding questions, I would say you can tackle any PySpark coding question because I will design those questions like that. Okay. Before that, let's upload our data. Okay. And let me just go to catalog. Let me go to interview catalog and source. And why I'm speaking so like this, because see, it's almost 1 a.m. right now here. So that is why. So no worries at all. My mic is so good. I know. Okay. Now let me quickly upload some data in the volumes. Let me go here in the volumes, and within this, let's create a new folder. Let's say create directory. Let's say PySpark. Yeah, PySpark. Okay, good. So we have this particular folder called PySpark. Makes sense? If you will see, we have PySpark. Okay, now let's click and hit this button, upload files, and let me just upload some files here. These are the 3 files that I have uploaded. Don't worry, each file is uploaded in my GitHub repo as well. You can download and upload it here as well. Let me click on upload. Perfect. See, dim airports, dim passengers, fact booking CSV. This is our source that we will be using for our coding questions. Make sense? Good. Now let's go to recents and not recents, go to workspace. Go to Databricks PySpark interview. Let's create a new notebook. Perfect. Let's have some space. Let's rename it as, let's say, PySpark coding. Perfect. Now I will start my PySpark coding questions, and you already know that we have these sources, right? Perfect. We have volume, we have this folder PySpark, and we have 3 files here. Perfect. Now let's see what is our question number 1, and let me just quickly show you how our data looks like just for the exploration. I will just put, let's say, exploration. Perfect. I will quickly say select asterisk from csv dot backticks and then this thing. Perfect. Let's see what do we have. So this is like dim airports.csv. This is a dimension table that we are using. Okay. Dimension airports.csv. Let's see what do we have inside this. And this will simply return me, I think, just CSV, nothing fancy. Bro, it takes some time when you run it and attach it for the first time. It's fine. And you know what? I'm so hungry right now. I don't know what to eat. My coffee jar is empty. Okay, now, okay, this is my dim airports. Okay, now let's try to look at the data that we have for dim passengers. Perfect. Okay, then we have fact bookings as well. Let's look at that as well, because this will give us some visibility while performing some questions, while solving some questions. Fact bookings. So perfect. So this is our data. Makes sense. This is just a fact table for bookings, like all of the bookings. Here we will be having all the IDs because this is a fact table. And then we also have some, you can say, passengers information, right? Very good. And here we have some information regarding the airports as well. Perfect. Now let's try to solve some PySpark coding questions. Okay, let's see. So here comes our question number 11. And this is like pure coding question, as we know. And the further questions will be also some coding questions so that you have some good understanding of PySpark questions as well. Make sense? Good. So now the question says, you work as a data engineer at an airline company. The business team wants to understand how flight ticket sales are trending over time to plan pricing and promotions. Because obviously, if you are working in an airline company, if you have dream to work in an airline company, it's good because there are so many product-based companies which are really, really big, right? So now they want to understand the pattern of their sales using PySpark. Now you as a data engineer need to use PySpark and you need to analyze the trend of flight ticket sales over time. It can be daily or monthly. Understood the requirement? Very good. Let's jump on to our Databricks. So let me just write it here, question number 11. And actually let me do one thing. Let me just copy and paste the question as well so that you can navigate the question in the notebook as well. Both the things, right? So what you can do, you can just copy and paste this thing, right? And perfect. So here we have our question number 11. Perfect. Now let's try to answer this question. Okay. Like I try my best to make the coding question as well as similar or as equivalent to a real-time scenario, because in the interview, this language can be changed, obviously, but the intent, the code, the approach will remain the same. Make sense? So I am just trying my best to convert those generic coding questions in the form of situations, because situations can be changed, but the approach will remain the same. Okay. So you do not need to bother about the situation. You just need to focus on the approach. That's it. Okay. Make sense? Very good. Because I was just trying to think like how I can just provide you the best scenario. So I just asked ChatGPT as well, hey, what is the best kind of scenario for this particular coding question? Because see, this question can be asked like this as well, like in the form of, you can say, question, hey, what are the sales, what are the trend, or what's the trend of the sale? Like what's the trend of the sales, whatever. But I wanted to keep it more realistic, more scenario based. So that is why we will be tackling coding questions as well through the realistic standpoint, a real time scenario standpoint, not just like basic coding questions. Because in the interviews, they will not ask you directly, hey, write a PySpark code using GroupBy. Hey, write a PySpark code using join. No, they will give you the situation. Now it's my responsibility to make you aware about how to tackle the scenario based coding questions as well, how to think like that. So first of all, if you just look at the scenario, you have these tables. Okay, they will not ask you like which table you want to use. It's your responsibility to tackle everything. So first of all, you need to understand like what do you want to do. You want to find something called as trend. Now what is this trend? Trend over time. That means you want to find the sales, the revenue your organization is making over time. Oh, let's say daily trend, monthly trend, whatever. So you need to first of all figure out in which table I have this data. So I have this information in this table, amount and booking date, right? Amount is the amount and booking date is the booking date. So I can leverage this thing. Make sense? So let's try to do that. Let me just create a data frame. Spark dot read dot format. The format is CSV. Then I will say dot option header true, infer schema true, right? Then I can say dot option or basically dot load. Perfect. And I will simply give this location. Perfect. So if I say display df, I should see this data frame. Perfect. Make sense with the proper header. Now let's try to solve that query. So now what is the query? Now we need to find the trend. Okay, trend. Okay, now we know that we have so much of data here, right? So much of data. Let's try to find the trend over day to day. Like what is the day to day trend? Let's try to find that. Okay, so in order to do that, you would need to apply the grouping, the aggregation on each date, and then you would need to apply the sum on this particular column. Simple. Let's do it. I will say df equals df dot group by and let me just import all the functions first of all. I will say from PySpark dot SQL dot functions import asterisk because I want to import all the functions. PySpark dot SQL dot types import asterisk. Perfect. Now we are good to go with our coding. So I will simply say group by on booking date because this column name is booking date. Booking date, and I want to perform aggregation, and aggregation will be sum of amount, right? And I will simply apply an alias because which is a good practice. It's not required, but it's a good practice. Total amount. That's it. This is the df which will give me the total amount based on the each date. But after this, I also want to sort this data. So I'll simply say dot sort. Okay. I want to sort it on the basis of booking date. Okay. And by default, we sort it on ascending order, and that's what I want. Let me just click on display df. What I will get? I will get all the trend as per the day. Perfect. See, 24th of March, this much of amount. 25th of March, this much of amount. But I don't like this big numbers. Let me just do a round off as well. This is again a follow-up question. Yes, we're gonna follow our legacy. We're gonna add follow-up questions as well. So do not worry. So I will add round function here. Okay. Round function, and I will just round it to 2. Let's do it. Yes, because we just recreated it. So let me just rerun this thing and then this thing. Perfect. So now it looks much more cleaner. Okay. Perfect. That's exactly what we need to do. One more follow-up question. Interviewer can ask you, hey, you have provided me all the numbers. This looks good. But does that make any sense if I want to see the trend? Can I just figure out the trend like this? Obviously, no. In order to look at the trend, obviously I need to do some visualization. Does that mean I need to use matplotlib libraries to build that? No. Databricks has something called as built-in visualization libraries. Just click on this plus button. Okay, just click on visualization. What will happen now? You can build a line chart, and this is the thing that I want to see. Exactly, this is the thing. I have date on the x-axis, I have total amount on the y-axis. Let me click on save. So here is my visualization that my manager will want to see, or your manager would want to see. See, this is so clean and so obvious. I can immediately tell you what is a trend. So it is going up and down, up and down, up and down, and these are the peaks that we have hit around May 16th, and now it is going down. So this is the thing, and now it is again going up. So this is the thing, right? So that's how you can just analyze your trend. Okay, like if you just look at the trend, it is obviously going up, but yeah, you can see some daily fluctuations. Make sense? That's how you just do it. If you want to edit something, you can also edit it. It's up to you. Make sense? That is the thing. Very good. Now let's look at the next question. So here we have our next question, and this question says that you work as a data engineer for an airline analytics team again. The business wants to identify the top 5 airports based on total flight ticket sales for the last few months. How would you calculate the top 5 airports by total sales revenue? Explain the logic. So first you need to explain the logic, then you need to start the coding. Because a lot of people are very good at writing the logic, writing the coding, but very bad at explaining the logic. You need to be good at both of the things. Because see, I know round one of the interviews is just about coding. No one is looking at you. No one is asking you questions. You just need to write the code. But right after round one, in round two, there'll be a person, there'll be a senior technical person who will ask you the technical questions, bro. So just be good at explaining the logic as well. So how you can explain the logic? Let me just tell you. So you have read the question, right? So you will say, okay, this is a requirement. I have understood the requirement. So first of all, I need to know in which tables I have the required data. I want airports, I want sales. I will first of all figure it out if this information is available in one table or multiple tables would be involved. Let's look at the data sources. If I look at the tables, I have 3 tables. I have sales in the fact booking. Okay, this is my fact table. And my airport information is coming from the DIM airports. As you can see, I have the airport name as well based on the airport ID. So the logic is very simple. I will apply a join between DIM airports and fact table to fetch the airport name associated to the each airport ID for each sale. Then I will perform the aggregation. Then I will sort the data. Then I will fetch only the top 5 airports. This is the way to explain the logic. Now the person will say, okay, now you can just go ahead with the coding and just write the code. So let's do it. And in order to write the code, it's very simple. First of all, we will create the df join. Okay, here I will write df. First of all, I need to create a data frame for each dimension on and each fact table, right? So df, let's say passenger or not airport. Df airport equals spark.read.format and then dim airport.csv. Perfect. So this is my df airport. I know that. I will create df booking. Okay, and same thing, spark.read format csv. I can copy the code as well from the above. I was hoping that it will suggest me some things and I can save some time, but it's fine, bro. It's fine. Okay, perfect. Now I can say, what's wrong with you, bro? Okay. So now I can say fact bookings. Make sense? So we have both the data frames ready. Very good. Now we have both the data frames ready. Now what we need to do, we will simply apply a df join. And let's create one more df just for the future questions. It will save us the time, right? Df, let's say passengers, right? Spark.read.format. Yeah, perfect. This is just for the future questions. Okay, perfect. So df join equals df airport, or basically df booking dot join df airport. Order is very important. Make sense? Order is very important. Now we also need to define the ID. Make sense? Like what ID we are just trying to join. Okay, now there are multiple ways to define it. You can also use this syntax, dot syntax, but I personally prefer this syntax. Let's say airport ID equals to airport ID. Make sense? Now I will say which kind of join I want to apply. I will say how equals inner join. Not inner, I will say left join. Makes sense, because left joins are like safer joins. You do not lose any data. So I will apply left join. Okay. Now I need to define the columns that I want. Okay. Now I will simply say dot select. I want obviously airport ID. Okay. So I can say df basically booking of booking ID, or not booking ID, like airport ID. Airport ID. Perfect. Then I can also pass an alias, it's fine. Then I can also use something called as sales, because that's what I want, right? That's what I want. So I can simply say amount, column of, let's say amount. I can use any format. I can use df format as well. I can use column format as well. Why I'm using df format as well here as well? Because airport ID is in the both the data frames, so it can create an ambiguity error, like from which data frame I need to pick this column. So that's why I'm specifying I want to pick airport from the df booking. Make sense? Good. Now I want column of airport name. Airport name. Perfect. Perfect. Makes sense. Do we have airport name here? Because it is throwing red error. We have name. We do not have yeah, we have airport name. What's wrong with it? Maybe it's just like pseudo error. Airport name. Yeah, we have airport name for sure. We do not worry about your error. Perfect. Makes sense. Now let's try to look at df join. Like how does it look like? Perfect. If there are any errors, we are here to fix it. Path does not exist. Dim airport dot csv dot. Are you serious? It is called dim airports. Oh, it is called dim airports. Okay. Not a big deal. Not a big deal. Dim airports and dim passengers. Perfect. Perfect, perfect, perfect. Okay, perfect. I have created this thing successfully, and now I can see the airport name as well, right? Now what I will do, I will simply apply the grouping. Df join, or you can say df group equals df join dot group by, and then airport name. Okay. Then dot agg sum of amount, and not like this, like this, sum of amount dot alias, and then total amount. Perfect, right? So this will give me the total amount. Now I want to sort this data as well. Dot sort total amount on DSC. So now in order to perform DSC, there are two ways. You can either say dot DSC, or you can also say ascending equals to false. Okay. Now I also need to do one more thing. I can also say dot limit 5 because I just want 5, top 5, right? Display df group. Let's see. Perfect. That's what I want. That's what I want. See, I have all the top 5 airport names with the total amount. This is the highest one, then this, then this, then this, then this. Wow. I can also create charts again. Okay. I can say visualization and I can create bar charts like this. Perfect. Let's say save. Boom. And I can anytime switch to the table, switch to the visualization. Make sense? Make sense, make sense, make sense. That's how you can just perform this thing. Okay, now let's look at the next question. So this question is tricky. This question requires advanced PySpark skills, but I know my data fam. I know my data fam is very, very talented and they will definitely tackle this question as well. So the question says every booking generates a sale amount for a flight. Management wants to track monthly performance trends. Ansh, Lamba, we have already solved this problem. Hold on, bro, hold on. Management wants to track monthly performance trends, so they ask you to calculate a running total. Sales for each flight. Okay. Now, just to add more complexity, read the next line. But the total should reset at the start of every month. Okay. By the way, you can expect these levels of questions in your interview for sure. For sure. So now the question says that you need to find the running total for the sales every month, and that running total should reset every month. Here, your knowledge of window functions will help you tackle this question. Let's tackle this question one by one. Okay. Now we know that we have sales and date in one table. It's called DF bookings, right? Let me just show you. DF booking. Perfect. Now, do you know what? I want to find the running total based on a daily transaction, and then I need to reset this number every month. How we can just do that? So for that, I will first of all import from PySpark.sql.window, import window. Perfect. I need to import this. Okay. So let me just write the code. df running, basically df run equals df booking. Okay. So I am creating a new column called running total. So I will simply say dot with column, and let's name it as, let's say, running total. Makes sense? This is just a column name. Now what type of transformation you want to apply? I want to apply something called as window functions, right? So I will use aggregation function as a window function. So I will simply say sum of amount. Okay, sum of amount. Then I will simply say over. Over is the command that we use to convert any aggregation function into a window function. Make sense? If you have used window function is equal, you simply write sum of something and then over, right? So here same thing, we will simply say over, and then now we need to use window operator, window dot partition by. Okay, and I want to apply partition by on month of booking date. Make sense? This is my partition by. After the partition by, I will say order by dot order by. Now order by should be, tell me, order by should be just booking date. Make sense? Because you want to find the daily transaction. Very good. Simple. Now if I use this thing, this will give me the running total. Let's see. Display df run. Okay, let's try to see. Perfect. Now you can see that I am getting the running total on a daily basis. See, tuck, 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 tuck. Then second day, it is added. See, it has added this thing into this one. See, this is the amount. This is the amount. Wait, let me show you. So, okay. I got it. I think something is wrong. Something. This is not actually running total. This is the whole total. If you observe, this has added this, and then it has just provided the total number. And then the same thing here as well. Do you know what? It is not an error. It is an intentional error. Just to explain you how window functions work under the hood. Because this is really detailed thing. When I write this thing, okay, it has performed exactly the thing that I was expecting. I was expecting that it will do the sum on amount and it will give me the total thing and partition by on month. If I write the same code in SQL, it gives me the running total. But when I write the same code in PySpark, it does not give me the running total. It gives me the whole total, but based on the partition by this thing. Wow. Yes. So in PySpark, we also need to add one more thing. And that's make it a little bit complex, but it is worth knowing it. So you need to add here something called as, it's basically called a window frames. It's called frame clause. We have frames when we just apply the window functions. Okay. So the moment we are done with our order by clause, now we need to say, hey, we want to process our data from the previous record till the current row. That's it. Do not consider the frame as from the minus infinity to positive infinity. I will just explain you this thing, don't worry. So I'll simply say dot rows between, because this is my frame, rows between window dot unbounded preceding, then comma window dot current row. What will happen? And what is this? If we do not use this frame clause, do you know what it does? It takes all the previous records and it takes all the future records and it gives me the total sum. Okay. But when I specify this frame clause, rows between and this, I am saying, bro, if this is a row, okay, give me this amount and just stop it there at the current row. Then if you go to next row, then stop it there. Then if you go to next row, then stop it there. Do not count the data for the future rows. And let me just show you this, how now you will see the data. Now it is working absolutely fine. See, currently I am seeing 1086 exactly. Then it added 377 into 1086 and it stopped. It did not calculate the data for the future records. Then it added 826 and it stopped. Then 1309, then it stopped. So this is called the running total. And in PySpark, you need to do this complex thing on your own. And it is by default in SQL. Okay. But you should know how to work with frame clauses, how to change the frames. See, competition. Ansh Lamba. Don't worry, bro. I'm here. Okay, makes sense. Now I hope you can tackle these complex questions as well in your interviews. Let's look at our next question. So now let's look at the question number 14. You are assigned to find the revenue generated by each city so far and tag those cities as high, mid, low based on the revenue buckets. If the revenue is less than 1000, tag it as low, between 1000 to 10,000, mid, more than 10,000, high. This is the question that you will see a lot because this is directly aligned with the conditional logic, and this is very important question. Okay, makes sense. Let's try to see how we can just tackle that. First of all, we need to find the revenue by each city. Then we need to apply the condition, right? Let's do it one by one. So I will simply say df, and we know that we would need to apply the join between booking and I think airport. Yes, because we have city here. Perfect. So now let's see, df equals df booking dot join df underscore airport, right? And then df booking airport id equals to airport id. Perfect. Then we need to select airport id, amount, airport name, not airport name, we actually want one more column which is called city. Perfect. Let's try to see how this data look like. Make sense? Then we will just perform our next step. And actually let's perform the group by as well, because it's just like one more transformation. So I'll simply say df equals df dot group by on city. Then I can say dot agg sum of amount. Okay, makes sense. Now let's see that. Display df. Perfect. Let's see our data. Perfect. I can see that city and amount. Perfect. Makes sense. And I can also say alias, and let's say total amount. Perfect. So now I have this thing. Now I need to create another column which will create a conditional tag. Make sense? So let's do that. So how we can just do that? I will simply say df equals df dot with column, and I will say tag. The logic is the thing. So now we need to write the conditional logic, and when we need to write the conditional logic, we use when otherwise statements. Okay, I will say when this column called total amount, okay, total amount is less than 1000, then do what? Write you can say low. Makes sense. And I will use lit function because this is a constant. Makes sense. This is a constant. Okay, this is just for the when statement. Now once this when statement is ended, now I will say this is low. Okay, now otherwise. Okay, or I can add one more when statement because we have three conditions. So I will simply say when column of total amount is less than 10,000, one more zero. Perfect. Then simply say medium, otherwise high. Simple. Let's try to run this. Perfect. As you can see, these are high because these are more than 10,000. We have all are high. Oh wow, man, all are high because all are more than 10,000. Okay. Let's change our logic. Let's say if they are more than 20,000, then only high. Okay, then let's see what happens. Okay, now we have medium and high. That makes sense. Okay, now it is good. Let me just change the logic here as well. 10 to 20,000 means mid. Okay, perfect. Makes sense. That's how you create the conditional columns in your data frames. Make sense? Good. Now let's see our next question. Question number 15 is my personal favorite among all the coding questions because this is something related to Python class / utility. If you have worked with PySpark, if you have worked with Databricks, you would have heard about something called as utilities because in the real world we use utilities a lot. What does it mean? In simple language, utility is something that makes your code dynamic. You do not need to hard code everything again and again. So for that, we can create a utility. For example, in this question, multiple source systems and data with different schemas, but all of that contains some common numeric columns that need aggregation. The business frequently changes which columns to aggregate, which aggregation function to apply. Hard coding logic every time is not acceptable. So now you as a data engineer need to build a Python utility so that you can perform PySpark transformations dynamically. And you will ask for these things in the parameters. Wow, let's do it. You will love it. And this is a question that is coming a lot in the recent interviews. So let me show you how you can just approach this. First of all, let's build a class, let's say called utility, or let's say my utility. Okay, class, and here I will create a method in itself. I can create that, but nothing is required here. Okay, let me just write it here, def. Then let's say I want to perform aggregation. So I will simply create a function called aggregator. Okay, I want first of all self as a parameter. Then I will pass df, then group by column. Then I will also pass the aggregation function. Aggregator column is obviously required plus aggregation type. These are the parameters that I will accept. Once I have these parameters, then I will simply say df equals to df.groupby.alias everything, return df. Simple. Make sense? This is my simple Python class. Now you can add hundreds of functions like this. This is just a piece of cake for the illustration. What this function will do, this will dynamically perform the transformation. So let's say I want to apply group by. Okay, for like today I want to apply group by on city, tomorrow I want to apply group by on maybe airport name, blah blah blah, so many things. Every time I do not need to write the code. I can simply use this utility. And how I can just use that, I will create an object. I will simply say object equals my class, which is my utility. Okay, then once this object is created, I will say df results equals, I will use that function obj, that is on object, then dot aggregator, and then I will pass the df. Now what is the df? Df is simple. Df is df booking. Let's say I want to pass df booking. Okay, then what is my group by column? I want to apply group by on airport id. Okay, airport id. Then I want to say aggregator column. Column is what? Amount. I can simply say amount. Make sense? Then aggregation type, I want to apply sum. Simple. Because see, my code is handling everything. This is aggregator column. This is aggregator type. Where is aggregator type? Wait. This is aggregation. This is aggregator column dot aggregator, then aggregator type, and then alias. Make sense? Make sense? Make sense? Now let's see the results. Display df results. Okay, let's see if it works. String object has no attribute agg. Let's see. Okay, because we didn't put the single quotes here. Perfect. Let me rerun it. String object has no attribute agg. Okay, let's try to see what's wrong here. Self is okay, df is okay, group by column is okay, aggregator column is okay, aggregator type is okay. Makes sense. And it is saying there's no type called string object is, oh, makes sense. Makes sense. We simply need to pass here column. Simple. Why? Because of the code that I have written. I have written .agg. .agg works only with column attribute. Make sense? Let me just run this. Column object is not callable. That is a different issue, but previous issue is solved. Let's see, like, what does it mean? Column object is not callable. Let me just modify the code. I think let me just do the traditional way to do this. So what I can do, aggregator type of aggregator column, that's it. Let's try this. And if I'm just using aggregator type, that means I do not need to pass this single quotes. Okay, and aggregator type, aggregator column. Yeah, perfect. Then I can also remove this column attribute. Let's try this one. So let's run this for one more time. Let's see. Oh yeah. So see, that's how you can create a utility that will run your code dynamically. There's no need to change your code. You just need to change the parameters. That's it. That is the power of utility. Make sense? Very good. Now let's try to understand this question. And this question is very important. Ansh Lamba, you say every question is important. See, I didn't say every question is important. Obviously, if I am creating a video like every question is important, this question is extra important. Just read the question, you will get to know why. You have a large data table in Databricks, billions of rows, used for analytics. Due to data privacy rules, you need to delete a small subset of records, maybe hundreds, okay? Frequently, for example, user requested deletes. It can be even less than 100. Rewriting the entire data files every time is slow and expensive. How do deletion vectors in Databricks help in this scenario? And I know a lot of you will say, hey, forget about how. We do not even know what are deletion vectors. Don't worry, I will just tell you. What do they do under the hood? How do they improve the performance compared to traditional deletes? That's why I said this question is extra important. First of all, you need to understand what are deletion vectors and what problem they solve, and here how it's gonna solve the problem. So let me just explain you. So let's say you are a user. Again, all the questions are here. Just enjoy and crack your dream jobs, bro. Enjoy. So let's say you are a data engineer. Okay. Let's say you are a data engineer. Now you have a big table, a very big table. Let's say billions of records. Billions of records. Okay, makes sense. Now you have billions of records. Now let's say, obviously when we have billions of records, there are Parquet files behind the scenes. Makes sense? So here we have Parquet files behind the scenes, right? Here you can say so many Parquet files. Parquet files. Okay, we have so many Parquet files, right? Let's say Parquet 1, Parquet 2, and so many things, right? Parquet 2 and so on. Now the thing is, whenever you delete some data, delete or update anything, okay? Just a pro tip, delete or update anything. If let's say you delete or update the data, in this case we are deleting the data, deleting some records. Let's say the data that you are trying to delete is in this particular Parquet file. Okay, let's say. Let's say the data is in this particular Parquet file. Make sense? This one, in this one. Okay. Okay, perfect. Let's say in this particular Parquet file. Simple? Very good. Now what will happen? Let's say this is your deletion. Okay. Now what will happen? This Delta Lake will create another Parquet file. These are the fundamentals of Delta Lake. If you have not cleared your Delta Lake fundamentals, bro, just go and clear your fundamentals, because this is the high time to clear those fundamentals. And if you do not have anything, just go on YouTube, just search Delta Lake full course Ansh Lamba. You will find the best resource for Delta Lake. Make sense? So what it does, it will rewrite this whole Parquet file and it will name it as, let's say, Parquet 3. Okay. And now what it will do, when you will be just querying this Delta Lake table, it will refer to this Parquet file and this Parquet file, because what it will do, it will rewrite this Parquet file, this Parquet 1, it will rewrite this and it will remove those records, and that's it. Make sense? Yes. So it will rewrite this Parquet file. Okay. Now just tell me one thing. I am saying that this in this Parquet file I have billions of rows. Billions. Does that make any sense to rewrite this Parquet file again? Does that make any sense? Obviously no. My headset. So, does that make any sense to rewrite this Parquet file, whole Parquet file? No, right? That's why we have deletion vectors. Do you know what deletion vector will do? Deletion vector will say, do you have deletion vector? Yes. If we have enabled the deletion vector, I will say the data that I want to delete is in this Parquet file. Okay. Now it will not rewrite the whole file. It will create something called as deletion vector. Okay. Now this deletion vector will store the information what records to delete. That's it. It can be metadata, it can be IDs, it can be anything. What records to delete. Okay, that's it. So what will happen? Now if we are just trying to read the data, we are reading the same files, but we have used something called as deletion vector. So we will not read those records which are deleted. So what will happen? In this Parquet file, the records will be marked as deleted, okay, using this deletion vector. So when you'll be just reading the file, reading the data, we will not display those records. This way, we do not need to rewrite the billions of records again and again and again. This is the power of deletion vector. Oh, okay. Now to answer this question, now what you need to do, you will say, I will enable deletion vector on this delta table, and under the hood, deletion vector will do exact same thing. You need to explain this thing the same way I have done that. Make sense? Make sense? Make sense? Make sense? And how they improve the performance? Because see, you do not need to rewrite the billions of records. Save memory, save storage, save efficiency. And now we are simply trying to mark those updated or deleted records as deleted or updated. And then we are not rewriting the data again and again. Wow. Literally wow. Yes. This is the power of deletion vectors. And I know deletion vector is not very known to everyone, because this is a kind of skill that only seniors have. Like the one who is like actually gone deeper inside the delta lake. Only those people know this thing. Or if you are following Ansh Lamba, then obviously you know this thing, because I love talking about delta lake. Make sense? Very good. Now let's see our next question. So this question can save your job if you made a big mistake. So let's say you are working on a delta table in Databricks that stores daily transaction data. While fixing a bug, you accidentally ran a delete statement that removed a large number of valid records from the table. I know this sounds scary, okay? The job completed successfully, but later you realize the mistake. Now, it's too late. How would you recover the table to its previous state using Delta Lake? Do you know what? There's a good news for you. If you made this mistake in Databricks, you can revert it. Really? Yes. There's an undo button. It's not Control Z. First of all, it's not Control Z. There's a command. There's a method. There's a way. There's a process to do that. It's called time traveling. Okay. So let's say you are a user. Okay. You are a user and you deleted this table. Not entire table, deleted some records. Okay. So what happens? You, when deleted the records, perfect. So when you deleted the records, let's say like this. So the moment you deleted the records, you will create a version of it. Okay. Yes. Every time you do anything in the table, you create a version for it, for everything. If you are inserting the data, if you are adding the data, adding and inserting, same thing. If you are updating the data, if you are deleting the data, you are creating a version. Let's say you inserted the data. Okay. insert, this will create something called as v0. Let's say v1, like anything, version 1. Now let's say you performed delete, right? This will create a different version, v2. Perfect. Do you know what? Now what you can do? Let's say you do not want to delete it. Now you can actually magically go to this thing. It's called restore. You can restore it back to version 1. That is the power of time traveling. You can do that. Literally, yes. Let me just show you with the help of an example so that you can understand better. So let's say we have, let's use this notebook, PySpark coding. Let me just show you. Or let's create a new notebook. Go to folder and let's create a new notebook. Create notebook. Let's call it as Delta Lake. Perfect. Now this is a Delta Lake. If you remember, we have one table. It's called sales, right? So let me quickly show you table. Select asterisk from, what was the catalog name? Interview catalog dot source dot sales. Perfect. So let's say this is the table. Okay. And in the meantime, I can write my update query. Let's say delete. Okay. I want to delete some records from this table. Delete from interview. So currently I have 4 records. Let's say by mistake, I ran this statement. Wow. Let's say by mistake, I ran this statement. Everyone knows what will happen. It will remove everything from the table, right? If I now query the table again, what I will see? Nothing. Wow. What is wow? Bro, all the rows are gone. Okay. Now you can revert it back. Let me just show you how. So for that, you first of all need to fetch all the versions of your table. And how you can fetch all the versions for your table? There's a command called describe history and then table name. Run this command and you will see all the versions created for your table. See, version 0, version 1, version 2. What is version 0? When we created this table. What is version 1? When we write some data. What is version 2? Delete. Now I want to go to version 1 from version 2, right? Let me just show you how I can just do that. I will say restore, okay, and then table name to version as of 1. I want to go to version 1, right? Let me just run this command. So this is now reverting it back to the version 1. Okay. Now let me just run this command for one more time. Basically this select statement. Now if I run this command, I will see my records back. Wow. Magic. And now if I see the version history, now you will see there is a new version called version 3 just for the revert. Describe history. Perfect. Perfect. 0, 1, 2, 3. Third is restore command. Told you. Same thing that I explained here. See? Wow, man. Literally wow. This is called time traveling. Okay. Now you can also perform select statement before restoring it. Let's say you do not want to directly restore the table. You first need to see what will be the result of that thing. You can run select statement. Select asterisk from table name version as of, let's say, 1. You just want to see like what will be the output before actually running the restore command. It's a kind of safer version. See, if you're satisfied with the results, simply restore it. Simple. Good. So let's talk about the last question of today's video, and I hope you enjoyed this video so far. And if yes, please drop a lovely comment in the comment section. Please hit the subscribe button and like button. It's 3:15 a.m. right now, and do you know what? I am putting so much of effort just for you. Your one like and one comment actually makes me feel happy. Okay, so just do it. Why are you so shy in doing that? Okay, let's try to understand this question, and this question will be like very good one, and just be with me. So the question says you have a delta table with 2 to 3 terabyte of data where new records are continuously appended. Earlier it was partitioned by date, but now queries filter on customer ID and region, and partitions are causing too many small files. How would liquid clustering help here, and why is it better than traditional partitioning? And now again, a lot of you will say, what is liquid clustering? Before telling you the liquid clustering, do you know what is a traditional partitioning we used to follow? You would know this, I'm so sure, because this is so common. So let's say you have this particular data engineer and you have this data, right? You have this table. Under the hood, everyone knows that this is a full of Parquet files, right? Full of Parquet files. But do you know what? We were not storing this Parquet file as is. We were not storing this Parquet file as is. We used to create folders. We used to create what? Folders. And folders were based on the partitions. Make sense? So let's say we have one folder here. Okay. Wow. Why it is like this? Because this is very small. So let's say this is one folder. Okay. This is one folder, and within this one folder we have this. Okay. Whoa. Bro, it's 3:15 a.m. What? So let's say this is a folder, okay? And in this folder, we have this Parquet file. Similarly, we have this folder here as well, and we have this Parquet file. Now, what is this folder? This folder is nothing but, you can say we have some data. You can say we have partition on basically year. Let's say 2023, and this is 2024. It can be anything, right? So this is a traditional way of partitioning our data. Traditional way of doing it. But do you know what? This approach is outdated because it is not very much performant in the modern era. We do not do this thing anymore. Okay. We do not do this. Now with the help of liquid clustering, we do not need to do any kind of partitioning. Okay. So what will happen? And how it will improve the performance? Because we used to do partitioning to improve the performance, right? Yes. So these are the Parquet files. These will be here as is, obviously. Okay, like this. Do you know what? Now if I enable liquid clustering on this, let's say enable liquid clustering, and don't worry, I will just show you how you can just enable liquid clustering. So now if you enable liquid clustering on top of it, now it will create a kind of logical clusters. What? Logical clusters, or basically partitions. Not physical partitions, logical partitions, logical clusters. So it will create logical clusters slash logical partitions on top of our data. So what will happen? So let's say data partitioning, or basically when we used to partition our data on any year, any column. So we were just creating small file problem, and we were just creating so many overhead to manage those partitions. But you know what? With liquid clustering, as the new data is appended, Databricks will automatically cluster the files based on these columns. What are these columns? The column that you will pick, Don't worry, I'll just show you the code as well, then you will understand. So you will pick some columns on which you want to create clusters. What will happen? The similar values will stay together, and this will help to fetch the data faster. Make sense? So it would require to scan less data and it will run faster. And you know what? The best thing about logical clusters, it will be ever evolving. It's not like you have created the hard clusters, it will be just evolving with the query patterns as well. Make sense? Now let's see the documentation. Liquid clustering. And this is a very cool topic. This is the latest topic in the world of Delta Lake. So let's see what is written here. Liquid clustering is a data layout optimization technique that replaces table partitioning and Z-order. If you do not know about Z-order is like something we were using with respect to optimize command. Okay, but it is also replaced using liquid clustering. Okay, and you can see it is updated on November 12th, 2025. So it simplifies table management and optimize query performance by automatically organizing data based on the clustering keys. As I just mentioned, we define the keys, we define the columns on which we need to define, on which we basically need to create the clusters. And it will manage that table around that automatically. Make sense? When to use liquid clustering? Tables that are often filtered by high cardinality columns. Let's say you have an ID column and in your dashboards you are filtering that data based on that column. So it is a high cardinality column. You can enable liquid clustering for that. Make sense? And this is the code to enable liquid clustering. I prefer using both the things, SQL and Python. So when you are using Python, this is the way to create it. Okay. And if you're using SQL, this is a better way and more readable. You simply say create table name, and you simply say cluster by the column name. There is one more cool feature. Sometimes people will say, I do not know what is the best column for my table. And do you know what? We have cluster by auto command as well. It will automatically pick the best column for your clustering. Let me just show you. See, this is cluster by multiple columns and cluster by auto. Where is cluster by auto? Like there's a command called cluster by auto. See, so it will automatically pick the column for you. This is amazing thing. And reports, or you can say some factual websites have shown that this is a very promising and very optimized technique and has actually optimized the performance by 10x, I would say, in most of the cases. So it is a very good optimization technique, and I'm so sure that you would get question around liquid clustering for sure. Make sense? Okay, I hope now you understood everything, and I hope you have a very rich understanding about Databricks and PySpark integration, and I hope that you will use this particular interview guide for your interview. I will post this whole guide in my GitHub repo, so that you can just revise just before sitting in the interviews and just carry that smile, carry that confidence, and just feel like I'm with you in that interview. Don't worry at all. Okay, and just go and sit in the interviews and just crack the interviews. And happy learning, bro. Okay, and just drop a lovely comment right now. Okay, and bye bye, see ya.